this is slide of all teachers, respected teachers, the best teachers. Great. And this I have to start isomerism today. Now let me check it out that I am audible and visible to all of you or not. Let me see. Let me check it out. Very good evening, my dear students. Am I audible and visible to all of you or not? Kids, just to let me know. If yes, I want to see green hearts, green symbol in the chat section. If I'm perfectly audible and visible to all of you kids. Welcome, Vanakkam, Suswagatam, Jo Bole So Nihal, Sat Sri Akal, Walaikum Salam, Assalamu Alaikum. This is your Baba HSP. If I'm perfectly audible and visible, I want to see green signal in the chat section. Harni, Chaitanya, wow Chaitanya, Amman, that's really fantastic, really fantastic. Good evening, hands, good evening, everyone, all my dear students. So today we are going to start with isomerism. Today we are going to start with isomerism, kids. This is the topic for today. But I want to see Josh in the chat section. Yeah, Chaitanya Mashkare, after so many days, long time no see, now see. Now, everyone, chat is running very slowly. Why is this so? Everyone, I want to see fire along with green hearts. Kids, what is this? Are you ready? If Josh is not high, then what's the benefit? Why I'm over here, kids? This is your Baba HSP and for you people. And first of all, I want to say, yes, the chat should run very speedily. And everyone, you have to mark your attendance in the form of hitting the like button. Yes, everyone, smash the like button, smash it out. And if you're really having full on Josh, I want to see chats running speedily. Yes, that's my students. That's really awesome. Let me check it out. That's what's going on. What's going on, kids? What's going on? Now, today, I will tell you structural isomerism, geometrical isomerism, optical isomerism. Definitely, structural isomerism is going to take very less time. Tautomerism definitely is going to take too much time. Then geometrical and then optical will take too much time, and then conformational. So my focus will be mainly on questions, but just to do the questions in the correct manner, we should know the theory behind it. If we are not having theory in our brain, we won't be able to do questions. But before I move ahead, kids, let me show you the team Phoenix All-Star Fast Track Reloaded batch for NEET 2026, 280 plus lectures, 15 plus tests, class 12th and droppers. This is the huge team. Kids, can you see? Yes, the best faculties in the world. Kids, the best faculties. And now, if you want to enroll, then the price got, yes, it's only 2,799. in place of 3499. And let me tell you one more thing, my dear students, that if you really want to unlock big discount, that is of 20%, now this offer is valid just, yes, up to November 22. Yes, now only 2 days, kids. Yeah, now what code you are supposed to apply? Just to let me know, the code is HSP10. Remember this code, HSP10. This is the code, right? Now I'm going to start with the chapter Isomerism. Everyone, I hope that everyone is ready. Yes, so let's set go. Let's set go with isomerism. And suppose that if you don't know the isomerism, let me do the classification of isomerism first, kids. Now, kids, number of people, they are thinking that the definition of isomerism is, in the starting class 10th, we have studied compounds having same molecular formula but different structural formula. That is absolutely a wrong definition, or better to say, that is valid only for structural isomerism, but that definition is not valid for all type of isomerism. Everyone, I would like to give you the offline atmosphere, but the offline and online, the best thing is that if I'm writing something over here, that we are able to attempt questions in the form of poll, and poll I will give. And what form poll I will give? That frequently, yeah, sir, please put frequently organic lectures. Oh my God, really you are liking what I want to see in the chat? Some kids are saying that put frequent lectures. Really you are liking organic lectures? I want to see. Then definitely I will go with frequent lectures. Everyone, just to let me know that you are really enjoying organic lectures, then definitely I will come every week. I'll be there every week. Yeah, I will move with basics. I will move with basics, kids. So let's see isomerism. What is the definition of isomerism, kids? Remember that isomerism definition is compounds having same molecular formula but different physical or chemical properties. Physical or chemical properties. Physical or chemical properties. Or both of them can be different. Either physical properties should be different or chemical properties should be different, or both of them can be different. Both the properties can be different, or both can be different. Now, my dear students, definitely some of you must be thinking, sir, why you are saying that the original one, which we know, that compounds having same molecular formula but different structural formula, that is being different? Prove it wrong. Kids, how many of you want that I should prove your original definition that you were having in your brain, that to be wrong? How many of you want? How many of you want? See, let me prove it wrong. If I say that I am having this compound, these are the two compounds. Chlorine, hydrogen, chlorine, hydrogen, chlorine, hydrogen, hydrogen, chlorine. This is known as cis form because both the two hydrogens on the same side. Now kids, don't worry. Right now I'm not teaching, I'm just telling you how your definition, the definition which 99.9% student knows, that compounds having same molecular formula but different structural formula, that is wrong. I'm going to prove that to be wrong. The two chlorine, they are on upside of this ring. This is cis form and this is upside and this is downside. So this is transform. Now kids, what will you say? Their structures are same or different? Answer is their structures are same. Why? Because this is 1-dichloro, 1,2-dichlorocyclobutane, 1,2-dichlorocyclobutane. That is also 1,2-dichloro cyclobutane. Both of the two are having same structure. Both of these two are having same structures, but their physical properties are different. They will have different melting and boiling points. Mark my words, clear. Whatever I'm telling you kids, is it clear? They will have different physical properties, that is, they will have different melting point and boiling point. Now kids, so from today, never say that the definition of, yes, isomerism, whatever you were knowing, only there are few students, those who knows the correct one. So see, this I have proved that they are having same molecular formula, same structure formula, but their physical properties are different. They are isomers, they are GI, but their structure is not different. Let me give you one more example. For example, if I say this is lactic acid, CH3CH OH COOH, and its mirror image. I'm not teaching right now, I'm just trying to prove it. I'm not trying, I'm just proving it, that whatever you were having in your brain, that's absolutely wrong. So its mirror image will be like this: CH3 COOH OH and H. This is dextrolactic acid, D-lactic acid, and that is L-lactic acid. They are enantiomeric pair. Right now I'm not teaching enantiomers. I'm not right now interested in optical isomerism. I'm just giving the example that they are enantiomers. Now you see, if I talk about their IUPAC is 100% same. They are having same structure, but then also they are isomers. So because their properties are different, either physical or chemical. The physical property, that is their rotation towards plane polarized light, that is being different. That's why they are isomers. Their structure is not different. Their structure is 100% same structure. Remember that. They are having, both are having same structures. Both are having same structures, same structural formula. Only that rotation of light, their behavior is different. Now, I have proved myself. Those who are really liking it, whatever I will say, I will prove it. I will not talk anything. I will not teach anything without any proof. Those who are really loving it, kids, I want one thing from your side, that everyone, I see number of students are there, but like buttons, you have not smashed it. Kids, I will give you the quality. You have seen the previous NTA paper, physics was very tough, chemistry was tricky. Now this time definitely chemistry will come on the tougher side. I will give you the content that is equally good for IIT JEE also, so that you can solve any question. All the questions should look like easy peasy lemon squeezy. Once you are able to understand, I want to see green fire in the chat section and everyone hit the like button. So now I'm moving ahead. Let me do the division of isomerism division, right? So I would like to say, I will not start from here. I will start from somewhere else. If you see any two compounds, see I'm moving in a different way. Two compounds, if their molecular formula is different, if you see any two compounds, if their molecular formula is different, then will you say is there any relation? Then one thing is possible. If their molecular formula is different, then one thing is possible. What's that? Kids? That they may be homologous compounds. Remember that, homologous compounds. Now what do you mean by homologous compounds? This is not isomerism, but we should remember that they may be homologous compounds. Now what do you mean by homologous compounds? Homologous compounds have same functional group. These are having same functional group, but different molecular formula. Due to difference in at least one CH2. What do you mean by one CH2? One CH2 means at least one CH2. 14 AMU or 14 gram. If I talk about moles, 14 gram. If I talk about one entity, then 14 AMU. That is the difference, my dear students. That is the difference. Now see, starting should be done from isomerism, but I have not started from the isomerism, because if they are not isomers, they can be homologous compounds. Kids, are you getting my point? Now, what do you mean by homologous compounds? For example, if I say CH3OH and CH2OH. Now, their molecular formula is different, entirely different. So what I will say? I will say what they are, what the relation they are having with each other. They are homologous. Now, my dear friends, if I say molecular formula is same, two compounds having same molecular formula, then what do you think it's? Same molecular formula. If they are having same molecular formula, then two possibilities are there. Remember that two possibilities are there. What are these two possibilities? Possibility number one, they can be identical. If I say they are identical, another word for identical is they are homomers. There I have written homologous. Here I am writing homomers. They are different. Homologous and homomers, they are different. Or they can be isomers. And if they are isomers, then two possibilities are there. They can be structural isomers. or they can be stereoisomers. My dear students, always mark one thing in your brain. Always, I would like to say always, if anything is showing structural isomerism, if two compounds are having the relation of structural isomerism, they can never be stereoisomers. So before moving towards stereoisomerism, always focus on structural isomerism. Always give preference to this. Without this, you can't move in that area. Remember that. Everyone getting my point? See, kids. Number of times what happens that there are three modes. One mode is offline teaching, another mode is plus classes, and third mode is YouTube classes. Number of times I have seen that on YouTube classes that the bond between a teacher and a student is not exact. If I say that in plus classes I always feel bonded with these students because whatever I'm asking, they are giving the correct answer. They are having huge respect for Baba. Even you can have kids. I'm not saying that. But one thing is I found missing on YouTube classes that whatever I'm asking, you're not giving a quick response, and some of you are even not responding. Second point is that whenever you want, you can leave. That's not good, kids. When I'm teaching you like my kids, I'm teaching you for the rank, then kids, to every action there is equal and opposite reaction, you know very well. So what I should get from your side? I should get the response from your side. Structural isomer can never be stereoisomer. Very good. I remember, Annie, I remember. Right? Right, kids? Now, from this slide, we can see a structural isomer can't be. Structural isomers can't be stereoisomers, can't be stereoisomers, right? Everyone, are you getting my point? This point? Now, let me move towards structural isomerism. Now, my dear students, if you want to see structural isomerism, I can say one thing you should always remember in your brain. These are also known as constitutional isomerism. Everyone say constitutional isomerism or constitutional isomers. Everyone say along with me, constitutional isomers. Their IUPAC name will be same or different. Do let me know in the chat section. Yes, S. Kumudhu, yes, Kumudha, I remember, I do remember. Their IUPAC name must be same or different. Do let me know. IUPAC must be different. IUPAC name must be different. These 3 points you should keep in your brain, and there is nothing to visualize in this because it's two-dimensional. This isomerism is two-dimensional. This type of isomerism is two-dimensional. By seeing the simple structure, you can find out whether they are structural isomers or not. And in structural isomerism, the preference order must be like, write your famous position. Write your famous position. What I have written, kids? Write your famous position. So who is the one on first priority? R for ring chain isomerism. Ring chain isomerism. Then Tautomerism. Then functional isomerism. Then Metamerism. Then chain isomerism, then position isomerism. I hope. Now, why I am writing this? What's the trick for this? Write your famous position. What I have written? Write your famous position. Now, whenever in two compounds there is more than two type of isomerism, that is structural isomerism, but examiner has given the option just mark one. So out of, if I say two compounds are ring chain isomers, at the same time they are functional isomers, so which one I have to tick? Definitely the priority is having ring chain isomerism. Then I will go for ring chain isomerism. Okay, now kids, first one is chain isomerism. Chain isomerism. Compounds having same molecular formula but different parent chain. Different parent chain. Now I will start with three questions. Compounds having same molecular formula, same molecular weight, same empirical formula, same empirical weight. All four are same. Molecular formula is same. Molecular weight is same. Empirical formula is same. Empirical weight is same. All these are same. But only what is different? Different is parent chain. Now, how the examiner is going to ask question? What type of question will be asked by examiner? Just see. Questions. Find out minimum number of carbon atoms required to show chain isomerism in A. alkane, B. alkene, C. alkyne. Yes, everyone write down your answer in the chat if you know. I'm waiting for your answer, kids. Alkene, alkene, alkyne. Those who are asking for speed, I want to see your answer in the chat. Everyone. I don't know about the time, how much time it is going to take. I will just focus on study. I would like to tell you each and everything. How many of you are there? Four, 4, 5. Let me check it out. That 4, 4, 5 is correct answer or not. Let me write down 4, 4, 5. Kids have written like 4, 4, 5. Let me check it out. For alkane, N-butane and isobutane. So this is absolutely correct, kids. N-butane and isobutane. For alkene, CH2 double bond CH, CH2 CH3, and CH2 double bond C, CH3, CH3. There the parent chain is 4 carbon, here the parent chain is of 3 carbons. Here also the parent chain is having 2, 3, 4 carbons, 1, 2, 3 carbons, 1, 2, 3, 4 carbons, 1, 2, 3 carbon pattern. Now alkyne, for alkyne just see CH triple bond C, CH2, CH2, CH3, and CH triple bond C, CH3, and CH3. Now kids, here if I am putting CH3, then this will have 4 valency, that's why it's not possible. So we need 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. I hope that everyone is able to understand. Do let me know kids, is it clear to all of you or not? Is it clear? Right. Now, if I say after this chain isomerism, if I talk about, yes, position isomerism, let's move towards position isomerism kids. On second number, we will deal with position isomerism. That is known as PI. Position isomerism is known as PI. PI, position isomerism. Now here, molecular formula will same, molecular weight will be same, empirical formula same, empirical weight same. What is going to be different? And remember that even parent chain is also same. Parent chain must be same. Only what should be different? Position of functional group or multiple bond or alkyl group must be different. Either of these three, anything can be different, right? Remember that kids, number of kids they are doing mistake over here, number of kids they are doing mistake. I'm not saying functional group should be different, no, functional group must remain same, only its position can differ, only its position can differ. First of all kids, whenever we are teaching on YT, our brain is always moving, how many students are there, how many views are there, how many this and that. I don't want to go with that kids. Those who are real students, do let me know that even there are 10 students, 5 students, 100 students, 50 students, I will teach them. I will go with the flow. I will not increase the speed because I'm not teaching for views. I'm just teaching for your selection. Let me tell you very clear. If you want to go, if you want to leave, you can go. I will not compromise with the content, with the quality, with the questions, each and everything. I will move whatever is required so that you should get full marks in the topic. Do let me know kids. Kids, I'm not like other YouTubers, those who are teaching just for views. Kids, just try to understand. I want to tell you each and everything in detail. I want to tell you each and everything in detail. Now see kids, how the question will come. How the question will come. Question will come. Find out minimum number of carbon atoms required to show position isomerism in A alkane, B alkene, C alkyne, and D any organic compound. Let me see what's your answer, kids. Everyone just do let me know in alkane, for alkene, for alkyne, and any organic compound. Just to let me know. Now, kids, those who are studying isomerism for the first time, I will tell you each and everything in detail. And those who know, just to let me know the answer in the chat section. What's your answer? Thank you, kids, thank you. Now see, kids, let me tell you, the answer is here 6, here 4, here 4, here 2. Now you must ask, sir, how is it possible? How many of you want to know in detail why these are the things which are being the answer? How many of you want to know? In the examination, if it is coming, you can directly tick, oh, sir, this is the answer, as you have already told us. But kids, see, let me explain. For alkane, just see, kids, if I take C6, H14, then only it is possible. Then only C. CH3, CH2, CH2, CH3, CH3. Another one. CH3, CH2, CH, CH3, CH2, CH3. Now see, kids, here the parent chain is having 1, 2, 3, 4 and 5 carbons, and here also parent chain is having 1, 2, 3, 4, 5. Both the two compounds, their molecular formula is same. Here the PC parent chain is having 5 carbon atoms. Here also the parent chain is having 5 carbon atoms. So they are not chain isomers because their parent chain is same. Only the difference is that in the first one, the position of alkyl is 2 and here the position of alkyl is 3. Only the position is changed. Kids, parent chain must remain same. Only the position should get changed. That is the phenomena for position isomerism. I hope everyone got it. Now, my dear friends, those who are not able to understand, how many of you want to know the simple logic? By chance in the examination, you're not able to understand anything, then what you will do? How many of you want to know the trick? By chance, if you have forgotten, you're not able to understand anything in the examination, everything is looking dark, then the trick. See, Baba HSP's trick. Baba HSP's trick. Whenever you are not able to understand, just apply simple logic CS number. CS number. You have to find out which number. What is your mobile number? What is your mobile number? But here, CS number. We are not going to talk about mobile number. What is your CS number? What is your CS number? Hey, everyone, Number of time it happens, you are always moving, you're watching these lectures, your eye is not getting comfort. Just stand up and say, what is your CS number? CS number. Always go with CS number. Now, what does it mean? C stands for number of carbons in the parent chain. Number of carbons in parent chain. And S means number of side chains starting with carbon. Remember that, starting with carbon. Now, my dear students, if CS number is coming different, then for sure it is CI. CI means chain isomers. And if CS number is coming same, and if they are isomers, they will be PI. Now let me explain with the help of example. First of all, this you got CS number. CS, it's not computer science. It is CS. C stands for number of carbons and in the parent chain, and S stands for number of side chains starting with carbon. Now let me tell you, let me show you. If I say that in the starting I have taken C4, H10, and I have written two compounds, CH3, CH2, CH2, CH3. This is N-butane. And this was isobutane. N-butane and isobutane, you are studying from class 9th or 10th. They are isomers. Now see, 1, 2, 3, 4. 1, 2, 3. Now let's find out CS number. For this one, CS number, number of carbons in the parent chain, 4 carbons. Number of side chains, 0. Its CS number is 4040. Now its CS number. Number of carbons in the parent chain, 3. Number of side chains starting with carbon, 1. Its CS number is 31. Their CS number is same or different? Do let me know in the chat section. Both the two compounds, CS number is being same or that is being different. Everyone just do let me know. Now their CS number is different. CS is different, so they are chain isomers. Am I right, kids? Chain isomers. Kids, if you are getting, then do let me know in the chat section with the green hearts, green leaves, whatever green symbol you are having, kids. Now, another example, if I show you CH3, CH2, CH2, CH3, CH3, and another one, for example, let me write down C6H14, this is one, this is another one, CH3, CH2, CH3, CH2, CH3. Now their molecular formula is same, but 1, 2, 3, 4, 5. Now its CS number is 5 carbons in the parent chain and 1 alkyl group is starting with carbon, so 51. And let me check it out. 1, 2, 3, 4, 5. CS number, 5 carbons in the parent chain and 1 side chain is starting with carbon, 51. Their CS number is same or different? Do let me know. Write down in the chat section. Their CS number is same or different? CS is same. CS same. So they are position isomers. Have you got it, kids? Everyone got it? Everyone got it? Do let me know, kids. Hey, pyara bacha. Everyone, do let me know you got it or not. Everyone, you got it? Now, another one, because we were dealing with this question. We were dealing with this question, kids. Find out minimum number of carbon atoms required to show position isomerism in alkane. Now time for alkene, alkyne. So alkene I can write down here only. Alkene one I can write down here only. Double bond position is 1. Now double bond position is 2. Same for alkyne. Triple bond position is 1. Triple bond position is 2. Now, these are very simple. Now, any organic compound. Any organic compound means we can take any functional group. Maximum people must got confused over here. They must have taken some functional group and they are thinking, why not this, why not that? Alkane means CN, H2N plus 2 only. Only carbon and hydrogen. CN, H2N, carbon and hydrogen. CN, H2N minus 2, carbon and hydrogen only. But they are saying any organic compound you can take. You are having freedom to take any organic compound. So I would like to go with CH3, CHCl, Cl. This is gem halide, gem, both together. And this is vicinal halide, vicinal. They are adjacent to gem halide, vicinal halide. So I hope this is clear. Till now, each and everything is clear. Keep on showing green symbol, kids. Everyone, kids, remember that if you're not showing symbol, somebody else will show something else. So don't forget to show symbol that everyone is getting, kids. Now, after position isomerism, I would like to go with ring chain isomerism. Kids, are you ready for ring chain isomerism? How is the Josh? How is the Josh, kids? Ring chain isomerism. Yay! Ring chain isomerism. Now, kids, compounds, one form is, one form is cyclic. One form is cyclic. Another form is, everyone, another form is acyclic. If you see something like this, one form is cyclic, another form is acyclic, then always remember that they will be ring chain isomers. In the starting, you will feel that organic chemistry pedicure radu customer, but at last you will say, it's romba sulubham. The things must be looking idiyappam murku in the starting, but later on you will say, oh, it's romba sulubham. Now see, kids, let me prove it. Let me prove this. Kids, please give me that atmosphere so that I can feel you. I can feel bonded with you. You can feel bonded with me. Some people are doing spamming. Kids, they will be a winner if you're not showing symbols. Whenever somebody is spamming, don't get irritated. Start putting green hearts, start putting fire. The one who is spamming, his comments will not be visible, kids. Whenever somebody is spamming, don't reply. Just start flowing green hearts and fire in the chat section. The one can't win with this number of people. The one cannot win with the number of, your strength is more. The one or two cannot be a winner if he or she is doing spamming. you start flowing number of green hearts, number of fire symbols. Then see, he will go away. Now, let me show you. Suppose if I say that I am having C4H8, C4H8, then I can write it like this. This is C4H8. I can write it like this. Now see, both of these two are having same molecular formula, CH2, 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 CH2. Their molecular formula is same. This is cyclic, this is not cyclic. Not cyclic I can write, or I can write acyclic, and this one is cyclic. So what is the relation in between these two? They are RCI, ring chain isomers. Now my dear students, remember always that one is being cyclic, another one is acyclic, so it is having double bond. Double bond means it is containing pi bond. Once it is going to react with the bromine water, what is the color of bromine water? Bromine water is reddish brown. Its color is reddish brown, and this will react and the color will get decolorized. Color will get decolorized. Remember that. So we will say it is unsaturated compound. This is being unsaturated. It is known as unsaturated. And this is having all single bond. It is saturated. Then they are always functional isomers. All RCI are always functional isomers. But if we are supposed to choose one out of these two, then remember that, write your famous position. Who is more important? Ring chain isomerism important than functional isomerism. We will give preference to ring chain isomerism. Everyone got it? Everyone got it? Till now, is it clear to each and everyone? Now, fantastic. Let's deal with some questions. Till now, whatever we have studied, let's deal with some questions. See kids. Find out total number of structural isomers for see kids, CH4, C2H6, C3H8, C4H10, C5H12, C6H14, C7H16, C8H18, C9H20, C10H22. Now let's see kids. These two will never show structural isomer. These three will never show. Don't have. Do not have. It will have 2. It will have 3. It will have 5. It will have 9. It will have 18. It will have 35. And it will have 75. Now kids, how many of you always forget these? How many of you are always having, yes, they are not coming to your memory, you forget it. Now I will give you trick to find out. See, I'm going to give you trick for these. Just see, the trick is trick to find out Baba HSP's trick. apply the formula total number of structural isomers is equal to 2 raised to power n minus 4 plus 1. Let's see. Let's apply this formula, right? C4H10. We know the answer is 2, but let's apply 2 raised to power n is number of carbon, 4 minus 4 plus 1. So it will come out 2 raised to power 0 plus 1, and anything raised to power 0 is 1. 1 plus 1 is 2. So for C4H10 we have got 2 as the answer. Now let's apply for C5H10. Let's apply for C5H10. Just see. C5H10 2 raised to power n minus 4. 5 minus 4 plus 1. So 2 raised to power 1 plus 1. So 2 plus 1, that is 3. We got 3 as the answer. It's working or not? Is this formula working or not? Kids, do let me know. Everyone just do let me know this formula is working or not. This formula is working or not? Definitely, of course, it is working. Now let's see. C6H14 2 raised to power 6 minus 4 plus 1. 6 minus 4. 2 power 2. 4 plus 1. 5. Now let's apply for C7H16 2 raised to power 7 minus 4 plus 1. 2 raised to power 3 plus 1. 8 plus 1, 9. Only up to here it is important. After this, trick might not work, because then we have to add 2, then 3, and then we have to cram it out 75. But up to 7 it is important, right? Yeah, this is only for alkane, and never go with the trick. Always apply your brain, okay? Now see, kids. Once, if you remember this, let's see, C4H10, the 2 isomers are N-butane and isobutane. And for C5H12, N-pentane. Isopentane. Neopentane. Now kids, once if you remember these 3 things, up to 7 carbons, then you can do any question by applying logic. Number of times students are asking, sir, is there any trick to solve these questions? I've seen that always you are asking, sir, is there any trick for solving these questions? My dear students, there is no trick. But if you want to solve it immediately, I will give you fundamentals. Always go with fundamentals. Let's see if this is the fundamental thing. Always remember that this is the fundamental thing. If you remember this fundamental, you can do any question. Should I tell you how the fundamental works, kids? How the fundamental will work? Let me explain. The question will be asked. Find out. These are the questions from NEET, AINS, JMains. Structural isomers for C4H9Cl, or they can give you C4H9Br, or they can give you C4H9I, they all will have same answer, 4, 4, 4. Now, number of times I have seen that kids are asking, sir, is there any trick? My dear friends, there is no trick. But if you go fundamentally, you will always get correct answer. On the same time, at the same time, if I say that if they are asking for C5, these two they will ask C5H11Cl, C5H11Br, C5H11 iodine, then their answer will be same, and that will be 8. 8. 8. Now, will you say, should we remember it? Should we cram it out? No, my dear friends, no cramming is required. Go fundamentally. Your fundamentals should be very, very strong. Let's see, kids. Let's see. Let me explain. See, for C4, H9 Cl, if I go, this chlorine must be have added in place of hydrogen. Before adding chlorine, its base must be C4H10 only. You must have seen one movie, Chandni Chowk to China. That one hero was not able to defeat its enemies, but then at the last his master said, go with your fundamentals, the thing fundamentally you are strong in. Then he was a chef. You know, that story you must have seen. Now see, kids. Now kids, see, C4H10, if I say C4H10 is like this, CH3, CH2, CH2, CH3. Number of kids are saying somebody is here. Kids, remember one thing. In this world, there are too many chaotic situations. Too much chaos is there. But you have to find out peace in the middle of chaos. Number of peoples will be doing these things. They will trying to divert you. This world is full of chaos. But don't trace them. Don't follow them. Don't feel angry with those people. Just do your work. I am the one who is never going to block anyone. Never ever I'm going to block. I enjoy when people, they are wasting their time. I'm thinking, hey God, I'm doing great work. I'm not like those people. Okay? Now see, kids. If I remove hydrogen from here, or if I remove hydrogen from here, they will give the same compound. Let's see what compound. If I remove hydrogen from here, I will get Cl, CH2, CH2, CH3, 1 chlorobutane. Or if I add hydrogen over there, then also I will get 1 chlorobutane. If I put hydrogen over here or here, I will get 2 chlorobutane. I will get 2 chlorobutane. So these are structural isomers. From this, I have got 2 structural isomers. So for C4H10, one is N-butane, another one is kids. Another isomer is isobutane. What is that? Isobutane is like this. Now kids, if you are really able to understand, do let me know from where I can remove hydrogen and put chlorine. I can remove from here, here, here. They are same. But if I remove from here, this is different. From here also I have got 2. 2 and 2, 4. That means C4H9 will have 4 monovalent radicals always. 4 monovalent radicals. So now it has become very easy. No need to cram it out. No need to go for any trick. We should remain fundamentally very strong. Kids, got it? See, kids, if Akash Singh is saying that I realized, sir, sorry everyone. See, can you see the change, kids? I'm getting that immense happiness that even a student, when he or she is getting rank, government seat, that kid is not getting happiness. If Akash Singh is writing, I'm sorry I got it. See, what can be more happier moment than this? Really, everyone, kids, you are my kids. May Almighty God bless you with all happiness and prosperity. Kids, I love everyone. This is Baba. That's why everyone, they call me Baba. I'm like this only. We all are God children, God kids, human beings, right? Really awesome, kids. Really awesome. No? Very good, Dhyan Tracker. Very good. Very good. Kids, you are lovely kids. Love you, kids. Now see, kids, for C5H12. Kids, am I properly audible? Am I properly audible, kids? Kids, do let me know. And hit the like button, kids. You are really loving me. Do you love your Baba? Do let me know. Do you love your Baba? If yes, why the likes are less? Put more likes, kids. Everyone, put more likes. Now see, kids. See, everyone. Are you ready? Is everyone ready, kids? Now, C5H12. How many isomers we have? Do we have for C5H12? We have 3. What are these? CH3 and pentane. Isopentane. Neopentane. Everyone say N-pentane, N-pentane, isopentane, neopentane. Let me check it out. Kids, everyone say N-pentane, isopentane, neopentane. Kids say. Everyone, I can't see the chats. What happened, kids? Is everything is okay, kids? I can't see the chats. Everything, yeah, now I can see. Now I can see. Now, N-pentane, everyone say N-pentane. Please say na. N-pentane, isopentane, and neopentane. Say, please, everyone say. Champa's promise, everyone say N-pentane, isopentane, neopentane. Now, if I remove from here one hydrogen, or from here, I will get 1. If I remove from here, I will get different. And if I remove from here, I will get totally different. 1 chloropentane, 2 chloropentane, 3 chloropentane, 1 chloropentane, 2 chloro. From this, I have got 3 monovalent radicals, 3. Now see in this, if I remove from here or here, that is same. If I remove from here, that is different. If I remove from here, that is totally different. and if I remove from here, that is totally different. I have got 4 monovalent radicals. Now this is brilliant question. Neopentane will just give 1 monovalent radical because all they are saying 1. Add them. 3 plus 4 plus 1. 3 plus 4 plus 1. That is coming out 8. So from now always remember that C5H12, then remove one hydrogen, C5H11 will have 8 monovalent radicals. 8 monovalent radicals. Kids, is it clear? Now let me tell you in shortcut, C4H9, do let me know kids in the chat, will have how many monovalent radical, and C5H11 will have how many monovalent radicals? Write down in the chat. This will have always 4 monovalent radicals, and that will always have 8 monovalent radicals. Then all the questions will get solved. If you remember these two things, all the questions will get solved immediately. Got it, kids? Everyone, is it clear? Everyone, Champa promise. Very good. Now see, if tough question is coming, see, if they are giving tough question, rank deciding question, find out all possible structural isomers for C4H11 nitrogen. Now what should be your answer, kids? What should be your answer? Now let's see how to do it. Just see, if I write down it for primary amine, how should I write down for primary amine, kids? I have to make it NH2. Then what I will left with? C4, 2 hydrogens gone over there, H9. Now do let me know C4H9, how many monovalent radicals? C4H9, how many monovalent radicals? 4 monovalent radicals. So 4 primary amines we will get. Now let's see about secondary amines. NH. Now this side ethyl, this side also ethyl, this side methyl, that side N-propyl, this side methyl, and that side isopropyl. So for secondary amine we have got how many? 3. We have got 3. Now tertiary amine, let's see. How many you will get tertiary amine, kids? Tertiary amines. Now nitrogen attached with 3 carbons, CH3 and ethyl. Only one possibility is there, 1. So how many all total, kids? We have got 4 1-degree amine, 3 2-degree amines, 1 tertiary amine. So we have got 8 as the answer. Till now everything is perfect, kids. So always go fundamentally strong. Never ever have faith on the tricks, formulas. You can just keep them in your hippocampus just to increase the speed. But once we talk about accuracy, we should always go with fundamentals. Now, kids, after this, metamerism. Are you ready for metamerism, kids? Before we move ahead, kids, do let me know everything you are able to understand. Till now, each and everything is clear, kids. Till now, each and everything you are able to understand. If yes, yeah, metamerism we have used. Who is this? Nihal Chintan Batina. Very good. You are so awesome. Really awesome. Annie Jena. Everyone, just to let me know. Everyone got it till now. Very good, kids. Metamerism. Compounds having same functional group. Remember that, same functional group. But different alkyl group at least on one side of polyvalent functional group Now kids, we have to focus on one thing. What does it mean, polyvalent functional group? Polyvalent functional group. Only one thing we have to focus on. What do you mean by polyvalent functional group? What does it mean, kids? Right? Right? What does it mean? Let's see. What do you mean by polyvalent functional group? Now see, I'm writing over here monovalent and polyvalent. Monovalent polyvalent. Monovalent will never show. They will never show. These may show. Let's see. If I write down alcohol, that in alcohol this side is fixed, right hand side is fixed, this can be changed, so it is monovalent, can never show. But on the other hand, R dash ethers may show. If I write down aldehyde, will never show because this is fixed, one side is fixed. Ketones may show. If I write down 1 degree amine, RNH2, that side is fixed, can never show. But if I write down 2 degree amine, may show, or 3 degree amine, may show. Why I'm writing may show? Once I'm going to tell you this in detail, then definitely everyone can understand. Now see, if I write down carboxylic acid, will never show, but on the other hand, ester may show. If I write down 1 degree amide, will never show, this side is fixed. But if I write down 2 degree amide, RCO, NHR dash may show, 3 degree amide may show. Now let me explain. Once things are clear, if they are having 2 valencies or more than 2 valencies, they are known as polyvalent functional groups. Now, polyvalent functional groups may show, but monovalent will never show. These will never show, right kids? These will never show. These can't show metamerism. The examiner is giving you this side thing. They will never show. Now, let me explain. If I take C4H10O, let's see, it will have 3 metamers. What are these 3 metamers? Let's see, kids. NH, this side I am writing CH2, CH3, this is ethyl. This side also I am writing CH2, CH3. This is 2-degree amine. Remember that functional group is 2-degree amine. This side is attached, one is ethyl. And on another side, this side also we are having ethyl. Now remember that to make metamer, the functional group should remain 2-degree amine, because primary, secondary and tertiary, they are treated as different functional groups. This I will teach you when I'm going to tell you functional isomerism, right? Now see, second one I'm going to make 2-degree amine NH. Now this side I have added methyl. This side I have added methyl. Now that side is N-propyl. Now they are different or not? Both the side they were ethyl, but in this it is being methyl and it is being N-propyl. Both are being different. I to just ask for at least one side, but both the side they are being different, then definitely it's very good. Now once again, if I take 2-degree amine, gets 2-degree amine, and over here I am writing methyl, and here I have written isopropyl. This is being methyl. This is being isopropyl. Now kids, if I say this is A, this is B, and this is C. Methyl and methyl, these two are same, but this is isopropyl and that is N-propyl. I said in the starting only, if at least on one side the alkyl group is being different, then definitely that is going to be known as metamerism. But my dear student, at the same time, if I say they are showing any other type of isomerism, then the answer comes yes. See kids, what other type of isomerism is there present over there? Just see kids. Here the parent chain 1, 2. PC is of 2 carbon atoms. Here the PC is of 1, 2, 3. PC is of 3 carbon atoms. So I would like to say A and B are chain isomers also. A and B are chain isomers as well as metamers. And here 1, 2, 3. Parent chain is of 3 carbons, but the position is 2. Here the position is 1. So at the same time, if I say B and C are position isomers as well as metamers. So always remember that metamers are always either chain isomers or position isomers. Can you see? Metamers are always either chain isomers or position isomers, but preference must be given to metamerism. Why kids? Because we know the trick. Write your famous position. Write your famous position. Who will get preference? Who will be preferred? This is metamerism and this is chain and position isomerism. This is more dominating. Got it, kids? I hope kids, till now whatever I taught you, it's very much clear to each and everyone. I'm just teaching you in the same way as we are teaching to other students from whom we have charged money, and the way I was teaching in offline classes from whom we have taken lakh 2 lakh, 3 lakhs of rupees, kids. All my dear students, just to let me know. Let me just ask for a glass of water. Just give me a sec, kids. I hope everything is on the right track, kids. Everyone is able to understand each and everything. If yes, please show me green symbol, green leaves, green hearts, everything, kids, so that I can move with functional isomerism. Before I move towards functional isomerism, I want to give you the knowledge of degree of unsaturation. Yeah, next hydrocarbon after completing this. Now, kids, if you really want to have good knowledge on functional isomerism, you should know degree of unsaturation. If you know degree of unsaturation, you can kill the questions. The questions will become easy peasy lemon squeezy, kids. Really, the organic chemistry is going to become magic. You will be able to understand each and everything. Mark my words, categorically, I'm telling you this particular point, that you will feel at the top of the world. Kids, everyone, whatever I'm asking, everyone means everyone has to participate. Everyone. Now, kids, everyone means everyone is supposed to participate. Once I have asked that, everyone write down in the chat, everyone has to participate. Now, see, kids, before moving towards functional isomerism, we have to understand what? We have to understand what? What I'm asking, kids? Degree of unsaturation. And no, understanding degree of unsaturation is not enough. We should know how to apply it. Are you ready? To understand organic chemistry, degree of unsaturation is the language, I can say. Degree of unsaturation is the backbone. What I'm saying, degree of unsaturation is the backbone, du or dbe or ihd, they mean same. Du means degree of unsaturation, dB means double bond equivalent, they all mean same. IHD means index of hydrogen deficiency. Kids, you are always asking for trick. Once you understand the language of chemistry, this is known as language of organic chemistry. This is known as language of organic chemistry, and once if you understand the language of organic chemistry, everything will become perfect. So everyone is ready to understand. I will give you first I will give you the visualization and then I will give you the formula, right? First, let's see this index of hydrogen deficiency. This is indicating that how many molecules of hydrogens are less. Just remember that this is indicating that how many, just like vitamin C deficiency diseases, scurvy, vitamin A deficiency diseases, night blindness, vitamin D, calciferol, that is known as calciferol, so it's diseases, rickets in small kids and osteomalacia in adults, protein energy deficiencies, kwashiorkor, marasmus, so something is less. So it is indicating that how many molecules of hydrogens are less. How many molecules of hydrogens are less? That is the deficiency. Let's see. Let me explain, kids. If I say that I'm having C6H14, this means perfect alkane, right? Nothing is less. Perfect alkane. It's saturated and nothing is less. Now, if I write down C6H12, can you tell me how many molecules of hydrogens are less? That should be the DU, degree of unsaturation. Its degree of unsaturation was 0. Now, how many molecules of hydrogens are less? Kids, do let me know in the chat section fast. How many hydrogen molecules are less? One molecule is less, so its DU is 1. Now, if I write down C6H10, just compare with this. We have compared over here. Just compare with this. How many molecules are less? Do let me know how many molecules are less. 2 molecules of hydrogens are less, so its DU is 2. Now, if I write down C6H8, once again compare with that only. How many molecules are less? Do let me know in the chat section, kids, fast. 3. So 3 DU. Now, if I write down C6H6 with that is the parent, compare. How many are less? 4. So its DU is 4. I hope everyone got the visualization of DU. The DU visualization is clear to each and every one of you. Now for this, 2 atom means 1 molecule. 2 atoms of hydrogen means 1 molecule, right? Now I am going to give the formula for this. Formula is whether your compound is CXHY or your compound is CXHYOZ, the formula will remain same. Both the two will have same formula for DU, degree of unsaturation. See what is the formula. DU is equal to X plus 1 minus Y by 2. Y by 2. X is number of carbons and Y is number of hydrogens. So for example, if I find out for this C6H14, just apply DU is equal to 6 plus 1 minus 14 by 2, 0. If I write down C6H6, apply for DU, X plus 1 minus Y by 2, 7 minus 3, 4. From the formula also the answer is coming same as we have done with the visualization. Is it clear, kids? Is it clear? Now, what is the sense we are getting from DU? Just see what's the sense we are getting from DU. That you have to find it out. First, I am going to tell you DU from structural formula. This DU we have got it from molecular formula. DU calculation from molecular formula. This was DU calculation from molecular formula, from Now I will tell you du calculation from structural formula. Your organic will become superb once you understand this, kids. Mark my words. Whatever I'm telling you, it's going to act as a magic. Number of du is equal to number of cycles plus number of pi bonds. This is the formula, number of cycles plus number of pi bonds. For example, if I say that I am having one cycle, its du will be 1. If I am having one cycle which is attached with one pi bond, then its du is 2. If I am having one cycle attached with two pi bonds, then its du is 3. If I am having one cycle unattached with 3 pi bonds, then its du is 4. You can see it's applicable or not. It's applicable. Now let me give you one question and let's see how many of you can solve that question. If I ask, calculate du for phenolphthalein, phenolphthalein. Now let me give you the structure, otherwise you won't be able. I want everyone's answer in the chat. Tell me what's your answer. I'm waiting for your answer, kids. Examiner might be not giving the structure, but right now here I have given the structure. This is phenolphthalein, an acid base indicator. Do let me know, kids. I'm waiting for your answer. 14. Kids have written 14. Let me check it out. Number of cycles are 1, 2, 3, and this is fourth cycle. Fourth cycle. Number of pi bonds 3, 3, 3, 9 and 1, 10. So total is coming out 14. Kids, you are awesome. Kids, who has given this 14 to be the correct answer? Kids, you are really awesome. Sai Kumar, Kavita, Ani, Harish, Soumya. Kids, salute, salute. 11, 11. You are really awesome. You are rocking, kids. Right now I'm feeling accomplished. I'm feeling accomplished, kids. Really, really, kids. Really. Now, what's the benefit? Application of du. That we should understand. Application of du. Kids, see, once you know this, you will feel awesome. Applications. Remember that if I say C6H14, its du is how much? Du is 0. That indicates compound can't be cyclic, can't be cyclic. You are always searching for the trick. Remember that your fundamentals should be very, very strong. No trick is applicable. No, nothing cramming is applicable. Just remember. Now, if I say C6H12, its du is how much? Its du is 1. That means it can be alkene, and if it is an alkene acyclic, it can't be cyclic. And if I say it is cycloalkane, it can't be alkene. That means either you can make yourself alkene with 1 du, or you can make cycloalkane. You can't be cycloalkene. Everyone got it? Because one cycle stands for 1 du. Then cycle can't be having pi bond. Cycle can't be having pi bond. Now if I write down C6H6, its du is what? Its du is 4. That means I can draw infinite. You know C6H6 is benzene. You know that C6H6 is benzene. Only this much you know. But I can write down C6H6 1, 2, 3, 4, 5, 6. Triple bond and triple bond. I can write like this. No problem. I can write it like this: 1, 2, 3, 4, 5, 6. Triple bond and 2 double bonds. I can write it like this: one cycle, then second cycle, but I am having 8 carbons. So one cycle, and I can write down like this another cycle. Now 3, 3, 6 carbon and 4 du, 2 and 2, 4. I can write like this. I can write it like this: 5 carbons, double bond, and double bond. Du is 1, 2, 3, 4. I can make any compound 1, 2, 3, 4, 5, and I can write it like this. And I can put double bond, I can put triple bond, and I can put double bond. Now, kids, number of structures I can prepare. I can make it like this also. I can make it like this also. Now, kids, you must have got shocked that, Baba, you are a teacher. How speedily you are making these compounds. How speedily you are writing these compounds. Now, kids, how many of you want to write it down like me? Now, see, just focus on number of carbons and du. Just focus on number of carbons and du. Forget about hydrogens. No need to count hydrogen. Just see. If I add 1 hydrogen, 2 hydrogens, 2 hydrogens, 1 hydrogen, just check. They must be 6 hydrogens by themselves. They are already balanced. 1 hydrogen, 3 valency, 1 hydrogen, 2 hydrogens, 1 hydrogen, 1 hydrogen. They are already balanced. Just see: 1 hydrogen, 4 valency, 2 hydrogens, 3 valency, 1 hydrogen, 2 hydrogen. Just check it out. They all are having C6H6 molecular formula. This is awesome thing, kids. Now let's see how many of you are really able to understand. Let me give you one question. Question is, which compound is not having molecular formula C5H10? Okay, C5H10. A, B, C D Now what's your answer? Do let me know. Fast, kids, fast. Do let me know what's your answer in the chats. Very good. Annie, Jena, Rising Star, both of your answers is absolutely correct. Why, kids? How you got it? This is the answer. Absolutely awesome, kids. Now see, all they are having 5 carbons, but it is having 2 rings, 1 and 2. So its du is 2. And the molecular formula is indicating its du is 1. If du is 1 and its du is 2, so molecular formula will not be same. Molecular formula will be different. Just check it out, kids. Just check it out. CH2, CH, CH, CH3. So its molecular formula is C5, 2, 3, 4, 5 and 3, 8, H8, which is not matching with that. Everyone got it, kids? Is this clear to each and everyone, kids? Do let me know. Show me green hearts if everyone got it, kids. Show me green hearts if everyone. Now, once this is clear, then I can move towards functional isomerism. I can deal with functional isomerism, kids. Functional isomerism. Compounds having different functional groups. Compounds having different functional groups. Now, kids, compounds having different functional groups. For example, if I say that I am provided with C4H8O2. Now, how many things I can frame out from here? C4H8O2. Just see. Without wasting time, without gaining more time, without having more time, I can do all the questions. Just see to it. I can write down 1, 2, 3, 4. Double bond OOH. How many DU have consumed? What is the DU of this compound? Its DU is coming out 1. So I have consumed 1 DU and 1, 2, 3, 4 carbons. Definitely this is going to be the correct answer. Now if I write down compound like this, so see, just check it out first of all. CH3, CH2, CH2, 3 to 5 to 7 and 1, 8. 8. If I write down like this, carbon, 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 double bond O and carbon, 1 DO have consumed, 4 carbons I have taken, 2 oxygens I have taken. Now write down hydrogen if you want to balance, or otherwise they will be absolutely correctly balanced. 3 to 5 and 3, 8. Now one more compound I am going to write, C4H8 O2. What can I write? I can write like this also. See, kids, C double bond C 2 3 and OH. I can write it like this also. C double bond C O carbon and okay, one is missing now. So let me put over here carbon and carbon. Let me put over here OH. Now just check it out. I am taking care of carbon, I'm taking care of DU, and I'm taking care of atoms, oxygen atoms, but no need to consider hydrogens. They are automatically balanced. Just see, if you want to check You can check it out. Just check it out. 2, 1, 3, 4, 2, 6, 7. Oh, 2, 3, 1 hydrogen over here, 8. Got it? Have you got it? So all they are functional isomers. So what are functional isomers? Just see, this is carboxylic acid, this is ester, carboxylic acid, ester, hydroxydiol, this is this. Now more compounds I can form. C, CH3, C, CH double bond O, aldehyde and one OH. I can form ketone also, C, 2, 3 and carbon. I can frame out all these things. Just check it out. No need to think about hydrogens. They are already balanced. Just see. Automatically they will get balanced. So no need to worry about functional isomerism. Whenever compounds are having different functional group, they are functional isomers. But then also, I don't know, Pallavi, how many hours it will take, but yes, I will teach each and everything. Just focus on that. As Baba is teaching you, you can understand Baba is going with each and everything. Baba is not going to skip even a single thing. Kids, can you see? Now it's tautomerism. Kids, tautomerism will take too much time. It's really the best, most important. Tautomerism. In this tautomerism, one atom is always moving. Who is that? Who is that atom? Hydrogen is always moving. As well as electron also moves. Through bond. So scientist says this as in one word, what they call it? In one word, they call it desmotropism. They call it desmotropism. Desmotropism. This is different from resonance. In resonance, only electrons move. But here, electron as well as atom is moving. That is the difference. Now, hydrogen will move from first atom to second atom. This is known as dyad system. Which system, kids? Dyad. First to third atom, this is known as triad system. First to fifth atom, it is known as pentad system. Now kids, this is most important. Triad system is most important. For dyad system, only one example we will study. Pentad system, only one example we will study, because that is only in syllabus. But triad system we will study in detail. So our focus are Josh should be very high to understand it. Kids, Karthik, welcome. Jaya Lakshmi, welcome, kids. You are my army, HSPN army. Kids, Tautomerism is the most important. That will be asked examination. Are you feeling getting connected as like offline? Kids, do let me know. All my dear students, are you feeling that you are connected like offline students? Do let me know in the chat section, kids. Now, let's see. The key word I am going to tell you, kids, diode system. If I talk about diode system, that there is the best example of diode system, just see. Hydrogen cyanide. Right now, hydrogen is attached with carbon. After some time, you can see hydrogen isocyanide, coordinate bond C. Now see, kids, 1, 2. Hydrogen was attached with first carbon atom. Now it is attached with second nitrogen atom. Hydrogen cyanide and isocyanide, they are functional isomers as well as they are tautomers. Remember that. Break I will give at 8 after 1 hour, kids, right? Okay, kids? Fine, kids, definitely I will give break, but 1 hour, after 1 hour, kids, right? Really awesome, kids, for understanding. Now these two are, what's the relationship they are holding? They are functional isomers as well as functional isomers as well as tautomer. Which one will get preference? Write your famous position, right? Your famous position. So who is more important, kids? Functional isomerism or tautomerism? This is preferred, so they are tautomers, right? Now if I go to triad system, kids, for triad system, just take the Brahmastra. Whenever you are not able to understand anything, take the fundamentally strong thing, that X double bond Y single bond Z and hydrogen is attached on Z. This should be alpha acidic hydrogen. So what is going to happen, kids? If I say 1, 2, 3, this hydrogen will move from 1 to 3 and double bond will come in between 1 and 2. That should be its tautomer. How it is going to take place, what should be the mechanism, I will tell you each and everything, right, kids? I will let you know each and everything. Just see, kids. If I say X, Y, Z, the double bond now is in between 1 and 2, and on third hydrogen has got shifted. Then what's the relationship in between A and B? What do you say? A and B are, what relation they are holding? A and B are tautomers. Let's see, kids. If I say that I'm having acetaldehyde, just find out it is having alpha hydrogen. Yes. If I say X double bond Y single bond Z, or you can say this is the functional group. This is the functional group, and directly attached carbon is known as alpha carbon, and this is single bonded, that is sp3 hybridized. So it is having 3 acidic hydrogens. 3 acidic alpha hydrogen atoms. But we are in need of just 1 alpha hydrogen. So see that hydrogen will move from 1 to 3. It will go to third atom and double bond will come in between 1 and 2. Now you must be thinking how this is happening, how this is taking place. I will tell you the mechanism. I will let you know the mechanism, kids. How many of you are really interested in understanding mechanism? Now see, kids, this is known as keto form. This is known as keto form, and that is known as enol form. Enol for double bond in, and for all, in plus all will become enol. But remember that they remain in equilibrium, and equilibrium mainly lies in the backward direction. Equilibrium lies in backward direction. So this is more than 99%. Its content is more than 99 and it is less than 1%. 99% is, it is less than, it is more than 99% and it is less than 1%. Thermodynamically, this data has been found and has been proved that equilibrium, thermodynamically, this data has been got that equilibrium is more shifted towards keto side. This is having benefit of 12 kilocalorie per mole. So if anyone is asking generally which form is more stable, kids, yeah, it's aldehyde, but we have to use general word keto. It's being aldehyde, but then also we will use general word keto, right? Keto and all, right? Now always remember that thermodynamically keto is generally more stable, therefore keto content will be major. Therefore keto content will be major. Now my dear students, if keto content is major, that means everyone will be able to do such type of questions. Then no need to frame out question. That means in chemistry there is nothing which we can say everything always. We call it exceptions, but there is no exception. But let me tell you, there are many cases where enol will dominate. Now let's see in the examination from where it will come. In some cases, this is important for examination. Important question will come from here. In some cases, some special cases, enol has been found to be more than keto content. Now what are these? Kids, let's see what are these special cases. Now we will study factors responsible. Factors responsible, nothing to be crammed, kids. Let's see factors responsible for making keto to be more stable. Remember that first factor is first factor. Most important question will come from here only, kids. If enol becomes aromatic, if enol becomes aromatic, remember that if enol becomes aromatic, then enolic content will be, mark my words, kids, then enolic content will be 99.99%. Drastic change, kids. See the drastic change, 99.99%. Things got changed, enol will dominate. For example, if I write down a compound like this, for example, if I write down a compound like this, kids, see, the hydrogen will migrate from this sp3 1 to 3. It will go from 1 to 3, and a double bond will come in between 1 and 2. Can you see what we will get? You will get a compound like this, kids. And now that was non-aromatic. I taught you in GOC. This is non-aromatic because it is sp3 hybridized, not planar. It's not planar. It's not planar. So not aromatic. And this is planar. And following Huckel's rule. Which rule? Huckel's rule. So equilibrium will lie toward that side. It will not go back side. So 99.99%. Is it clear? If yes, I want to see green hearts in the chat section. If it is perfectly easy peasy lemon squeezy, if you can feel it, what I'm saying, kids, if you can understand, do let me know in the chat section that everyone is able to understand, kids. Now another example, see, if I write down a compound like this, just check it out. These are sp3 hybridized. These are sp3 hybridized. These are sp3 hybridized. There are 8 alpha hydrogen atoms. There are 8 alpha hydrogen atoms, kids, right? Now, 3 times tautomerization will take place. 1, 2, 3. It will go over there. 1, 2, 3. It will go over there. 1, 2, 3. It will go over there. Thrice tautomerization. Am I right, kids? What will you get? Aromatic compound. 99.99%. It is fluoroglycinol. Right, kids? I hope that this point is clear. Now, one example, and I would like to say the best example of pentad system. See, pentad system example, here only, pentad system. Just see, this is very important example. They have asked in IIT number of times, in AIMS also number of times. Now kids will think that these hydrogens are attached to sp2 and they might be thinking that there is no acidic hydrogen, but remember that this is sp3 hybridized and these are two acidic alpha hydrogens. So how they will move? See kids, 1 2 3, this hydrogen will go from here 1 to third carbon atom and the double bond will come over in between 1 and 2. So how it will appear kids? It will appear like this. Now they have become acidic alpha hydrogens because they are attached with sp3 hybridized carbon 1 2 3. So it will move from here 1 2 3 and double bond will come over here. Now how it will look? Now it has become aromatic. Can you see kids? Now overall this hydrogen has gone to 1 2 3 4 fifth atom. So this will exist in main form. It will not come back. 99.99% 1 to 5 shift. Clear kids? I hope everyone got it kids. Do let me know. No, number of structural, that is wrong. Who has written sir in structural isomerism? There is no logic like that, okay? That's wrong. Now, everyone got it. Now, second factor. Second factor is whenever you provided with a compound like this, C double bond O, CH2, C double bond O, R. Now remember that where R can be hydrogen, alkyl, aryl, same or different. This is carbonyl group. This is carbonyl group. These are the two bodyguards of this CH2. Remember that. CH2 is flanked by two carbonyl groups. CH2, this is known as active methylene group. Active methylene group. Active methylene group. So this is highly acidic, active. So such type of compounds, whenever you see, then their enolic form will range from 76% to 99%. So definitely, whether I talk about 76, whether I talk about 90, whether I talk about 99, enolic content is dominating. Can you see kids? Who is dominating? Enolic content is dominating. Now let me write down kids. In this, if both the two are, case 1, if both are phenyl, then enolic content will be 99%. If one R, case number 2, case 2, if one R is phenyl, then enolic content will be 99. it's 90%. Case number 3 I'm writing over here. If both are hydrogen, then 77%. Case number 4. If both are alkyl, then 76%. So I have written the whole theory. Now you must be asking for why this is going to happen, how it is going to happen, kids. See, what's the reason for it? Just see, everyone. If I write down compound like R, CH2, let me take one example. CH3, C double bond O, CH2, C double bond O, CH3. First of all, see, this compound is having how many alpha hydrogens? 3, 2, 6 and 3, 8 alpha hydrogen atoms. Out of these 8 alpha hydrogen atoms, these are known as active methylene. Why these are known as active methylene? First question, this one arises. Let's see. If I remove this hydrogen, I will get a negative anion like this. Just you can compare by yourself. And if I remove this one, then I will get compound like this. Now, which one do you think is more stable? Conjugate base. Both are being conjugate base. This is X conjugate base. That is being Y conjugate base. Y conjugate base. What do you think it's? Which one is more stable and why? Which one is more stable and why? Then your answer will be, this is stabilized only by one side by resonance, or one side by minus I. But if you look at this conjugate base, it is doing resonance on this side, at the same time it is doing resonance on another side also, this side also, two sides resonance. So both side resonance. Am I right? So more stable. And that's why, remember that only this hydrogen will migrate. Now, why it is going to migrate and why the enolic content is more, that I'm going to come to that part. But before coming to that part, you should remember that which one is more acidic and why it is more acidic. Kids, are you getting my point? Now see, kids. Now, do you think this compound is keto? It is having any resonance? The answer is no resonance. This compound is without resonance. Now, once its acidic H is migrating from 1 to 3, it will go from 1 to 3, it will come in between 1 and 2, then C. CH3, C double bond O, CH double bond COH, CH3. Now see, kids. Pi bond, single bond, pi bond and lone pair. What do you think, kids? Conjugation and extra conjugation. This is known as extended conjugation from here to here. Can you see, kids? Stabilized by extended conjugation, and that's why its percentage is 76%, and this is just 24%. So the enol first thing is stabilized by what, kids? Stabilized by extended conjugation. First factor is stabilized by extended conjugation. Second thing is that there is what, kids? Can you see what is there? Everyone just to let me know what is there. What can you see? There is intramolecular hydrogen bonding, that is known as chelation. Stabilized by, kids, do let me know. Stabilized by chelation. And you can see somewhat partial aromatic character has been developed. You can see somewhat partial aromatization is there. Kids, everyone, this much is clear to each and everyone. Just to let me know. Everyone, just to let me know. Wow, kids, some people are really ring star, Hames, Sai Kumar. These kids are really awesome. These are really awesome kids. Everyone really doing very good job. Now, these are the two factors. These are the two factors which are responsible for making it. Now, see, kids, if both side, if I put, now, one question they have asked in year 2012. Just see what question they have asked. NEET question. That they have given like this. They have written here X, Y, and Z. And they ask that write down these three forms in aqueous medium, or their whatever the solution was there. They are in equilibrium. Arrange these three forms in decreasing order of their content. That was the question. Now, kids, we have seen right now this is 76%. This is 24%. Then definitely we know that hydrogen is not acidic or very, very less acidic. So it will be Z, then Y, and then X. I hope that everyone you got it. It's crystal clear to each and everyone. Is this clear, kids? Do let me know. This is clear. This part is being clear to each and everyone. I know that you got tired. You need break, but I will give you break just after half an hour, kids. Half an hour, right? Show me green hearts. Show me some fire in the chat section. If you're really able to understand each and everything, kids, I would like to see green hearts. Some fire, some emojis. Anything you want to write down in the chat section. How the studies are going on. Am I teaching from the scratch level? Will you stay up to the last? I will teach geometrical isomerism. I will teach optical isomerism. I will teach conformational. Say, make a promise that you will remain at the last. Don't make a promise with your Baba. Make a promise with yourself, kids. हाँ हाँ चैतन्य, ब्रेक थोड़ा ज़्यादा देंगे, बिल्कुल देंगे, बट आप बीच में कहाँ चले जाते हो? आप इमोजीज भेजते रहो, मुझे लगता है आप हो ही नहीं. यू आर देयर और नॉट? X and Z are same? No. Yeah, X and Z are same. No, 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 they are not same. This hydrogen is gone. Here that hydrogen is gone. Here double bond is on this second carbon. So they are not same. Just check. And any, they are not same. Just check it out. X and Z are not same. They are different. Just check it out. Everyone just check it out. X and Z are same or different? X and Z are same or different? Just check it out, kids. And those who are new, kids, hit the like button. Smash the like button, kids. Now, if I say, why in case of phenyl it dominates? See, kids. If I write down phenyl, now this is the keto form. Now see, kids, this benzene is stabilized by resonance. This benzene is stabilized by the resonance, but there is no resonance. Here, no reso. Here we are having stabilization by resonance. Here also we are having stabilization by resonance. But you see, it's enol form. Just focus on enol form. Can you see the whole compound is stabilized by resonance? The pi electrons are moving on the whole compound. Can you see, kids? It's moving like this. The whole compound is stabilized by resonance. Can you see compound? Can you see, kids? That's why this form is 99% and that is just 1%. Is this clear, kids? Now, two factors I have told you. Thank you, Chatra, welcome. Now see, kids. These are the two factors. Now see, kids, one note I would like to tell you. One note. One note I would like to tell you, kids. Esters do not tautomerize. Esters do not tautomerize. Now, why? What's the reason? Let's see the reason why esters do not tautomerize. CH3, C double bond O, O, CH3. Now, if I remove this hydrogen by chance, so it will become like this: CH2 negative, C double bond O, O, CH3. Now this negative charge electron will say to adjacent carbon, do resonance with me, but it will say I'm busy with someone else. I can't do resonance with you, so it will remain localized. Means can't do resonance. So this is highly unstable. That means this is not acidic hydrogen, not acidic hydrogen. If this is not acidic hydrogen, so it will not convert into this one, will not convert, so can't do tautomerization. One ester out of 1 million esters do tautomerize, so it will not tautomerize. Now see kids, at the same time, if I say a special case of ester ester with active hydrogen, ester with active hydrogen will show tautomerization. Well-known example of this is a compound which is formed by Claisen condensation. If you know Claisen condensation, you will understand. That is the compound, well-known compound ethyl acetoacetate. How many of you do remember this compound? EAA. What is ethyl? There is ethyl. This is aceto. And this much is acetate. Ethyl acetoacetate. Now you see two bodyguards. And this is active methylene group. Can you see active methylene group? Now kids, already there is a resonance. This compound is a resonance stabilized. Now if it is going to form enol, then also just see what is going to happen. There also it was resonance stabilized. Here also it is resonance stabilized. It is just getting one benefit. What's that? It got one benefit of chelation. Extra benefit is chelation. That's why it is 7%. It is 7% and that is 93%. Now let's see whether we will be able to solve questions or not, kids. Are you ready for seeing questions, whether we are going to solve questions? Okay, Chaitanya, very good, very good. Dedicated student. Chaitanya, very good, very good. Now, let's see how many of you are able to solve the questions. Are you ready, kids? Just after solving questions of tautomerism, I will give you one break, kids. But for that, you have to solve all the questions. Take it as a challenge. Are you? Are you ready, kids? Now see, kids. Question number 1. Which will not show tautomerism? Which will not show tautomerism, right, kids? A C6H5 CHO, B C. And your favorite option, D. I'm waiting for your answer, kids. Baba is waiting for your answer. Baba is waiting for your answer, kids. Yes, kids, yes. Fast, fast. Chai, oh my god, hymns. So lovely hymns. Now see, mixed answers are coming. A, B, C, D, all they are getting clicked. Kids, what's going on? This is not fair. This is not fair, kids. So, kids, the correct answer is, hey, Champa, mark the correct answer. D is the correct answer. Now, which one you want to know that why? See, kids, at this place, no hydrogen, no alpha hydrogen. Now, kids, here hydrogen is present, but will violate Braddock's rule. Bread and tomato, Braddock's rule. Braddock's rule will violate Braddock's rule. Now here all the hydrogens, they are attached with sp2 hybridized carbon. So all of these, one question. Many people have missed it. Then what you will do in your examination, kids? What you will do in your examination? Now, accept second question as a challenge question. Ready, kids? Are you going to accept? Which will show tautomerization. A. Formaldehyde. B. C. D. pH means phenyl. pH means phenyl. Now this time, kids, everyone, you have to prove yourself that yes, you can do it, kids. You can do it. I'm waiting for your answer. Soumya, Chaitanya, everyone, just to let me know. Ring star, Kavita, they have given the correct answer. That is your correct answer. This one. See, these are vinylic hydrogens attached with sp2, so they cannot go. But this is acidic alpha hydrogen atom. This will go, right? Now, next question. Ready, kids? Arrange the following. This is very, very awesome question. In decreasing order of enolic content. Arrange the following in decreasing order of what? Enolic content, kids, right? Tell me the order, kids. I'm waiting for your answer. Yes, kids. Let's see who is going to get the correct answer. Baba is waiting for your answer, kids. BACD. Somebody has given answer BACD. BACD. Huge round of applause for this kid. BACD's first ring star. Congratulations, ring star. You're really doing awesome job. Really awesome. It's absolutely correct, kids. Because its in all will be, B's in all will be 99.99%. It will be somewhat 76%. It will be 1%. And it will be approximately 0%. Kids, everyone got it till now. Is it clear? And have some water. Always keep yourself hydrated. Always keep yourself hydrated, kids, right? Now, kids, tautomerism is perfect. Now, some other type of tautomerism, because examiner can ask anything. Examiner is always interested in asking some type of questions that you will not be able to give the answer. Some other type of tautomerism, right? Let's see, kids. In this category, there is urea and isourea. Remember that, urea and isourea. Now, what is urea? NH2 CO NH2. And what is isourea? One H will go from there, NH COH NH2. This is isourea, right? Now next one is nitro and amido. Now, what is nitro and amido type? Let's see. CH3, CH2, N double bond O, coordinate bond O. Hydrogen will migrate from 1, 2, 3, and double bond will come in between 1 and 2. So it will be CH3, CH, double bond NOH. So that is nitro and that is amido. You got it? Everyone got it? Nitro and amido. Now, third one is kids, this is your Baba HSP. Okay. All the slides they have got completed. See how much I taught you kids. All the slides got completed. Amido and imido, amido and imido. What is this? Let's see. Amido and imido. Amido, what do you mean by amido? Amido is CH3, CONH2. Out of these two, which one is more acidic? These are alpha hydrogens, these are also alpha hydrogen, but negative charge is more stable on more electronegative. So this will go 1, 2, 3. Imido. So amido and imido. Can you see kids? Amido and imido. No books, only Baba's notes. That notes are more than sufficient. Follow my notes, you will get full marks, right kids? Are you getting my point? So now one question. Isomerism, tautomerism, I taught you kids. The whole tautomerism, the whole structural isomerism, I have told you kids. Now one question on the total structural isomerism. Are you ready for that kids? Is everyone ready? Then I will give you break. Okay, then you will get one break, right kids? Just after one question. Question is, find out total number of structural isomers for C6H12O2. C6H12O2, okay? Options, I am giving you options also. A, 4, B, 6, C, 8, D, more than 12. Yes, your time starts now, kids. Do let me know, kids. And Chaitanya, you have asked that please keep one class for more than 8 hours. Chaitanya, do you remember? Do you remember? Kids, what's your answer? Do let me know what's your answer, kids. I'm waiting for your answer, kids. Fast, kids, fast. I want to see some are writing 8, some are writing D. So the correct answer is, kids, should I tell you what's the correct answer? Trimurdad, I think I'm perfectly audible, kids. Do let me know. Trimudad is asking, can you increase the sound, please? Am I perfectly audible, kids? Do let me know. If yes, do let me know in the chat section. If I'm perfectly audible, kids, do let me know in the chat section. Yes, so you can refresh. Those who are having that problem, Tirumad, you can refresh. Now, kids, the correct answer is almost maximum people are getting failed. D is the correct answer. Now, how many of you want to know that why D is the correct answer? How many of you want to know, kids? How many of you are interested in understanding why D is correct? Maximum people have gone for C. Let's see why D is the correct answer. C12, C6H12O2. What's the DU for this? DU is 6 plus 1 minus 12 by 2. That is coming out 1. 1 is the DU. Now C6H12O2, let's see how to make it out. C6H12O2, I can write like this. COOH. Now, how many carbons are left? How many carbons are left? 5 carbons are left. 5 carbons are left. How many hydrogens are left? 1 has gone. So, H11. Now, kids, have you done this one? C5H11 will form how many monovalent radicals? Do let me know in the chat section. In the starting, when the class started, I told you already, I taught you that how many structural isomers for C5H11 monovalent radicals. 8 monovalent radicals. Are you getting my point? So I have got 8 with this one. Now, if I'm forming ester, if I form ester C double bond O, CH3, how many carbons are left on this side? 4 carbons I am with. How many hydrogens? 3 gone. From 11, 3 gone. How many are left? C4. Tell me, 3 hydrogens have gone from 12. From 12, 3 gone. We are having 9. Now C4H9 forms 4 monovalent radicals. Got it? Now these I have got only acyclic one. 4 plus 8, 12. So these are, I am having 4 plus 12. Sorry, 4 plus 8. These I have got only acyclic. Now I will make ether, hydroxyaldehyde, cyclic, more than, it will go to more than 100. It will more than 100, kids. It will become more than 100. Are you getting my point? Number of others, cyclic, then hydroxyaldehydes, number of hydroxyaldehydes, number of hydroxyketones. Are you getting my point, kids? Etc. That means we will get many. So I hope that everyone is able to understand why the answer was more than 12. Why I have written the answer is more than 12. So no trick is applicable. Just you should be very, very strong fundamentally. Are you getting my point, kids? Are you getting my point? Now it's 8. Let's meet at, it's a dinner break, kids. Let's meet at, tell me the time, kids. (8:50 p.m.) It's right. Right, kids? You can recharge your battery, you can recharge yourself, have some water, have some food, have some rest. Okay? Right, kids? Okay, kids? But make a promise that you will come with what? You will come with lot of energy, lot of ATPs, right, kids? Just do let me know. Will you come? Oh, great, Karthik, great. First of all, do let me know you are excited for the questions of GI as the topic is moving ahead. Toughness of the concept is going to increase. Thank you, thank you. You kids are thinking for me, kids. Wow, that's really awesome. That's really awesome, kids. Okay, let's meet. Okay, kids. Okay. Everyone, are you back? Just to let me know, kids. Baba is on time. So let's it go. Let's start with GI, Geometrical Isomerism. Do let me know, everyone. It's time for GI, Geometrical Isomerism. Are you back, kids? Just to let me know. I want to see green heart. Kids, where are you? I can't see anyone. Any fire, any emoji. Yeah, now I got it. Rising. Welcome, 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 kids. Welcome. Geometrical. Isomerism. Isomerism. Everyone, I want to see green hearts from your side. These are known as GI. What I will say, GI, Geometrical Isomerism. Gets fast, 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 fast. Everyone, are you back with full of ATPs? What is written over here? I will write down once again. It's not looking good to me. We are going to deal with Geometrical Isomerism. Gets Geometrical Isomerism. So once I can see green hearts, green signal from everyone's side, then only I'm going to get start with this. Otherwise, I will not start, kids. Geometrical isomerism. Geometrical isomerism. Let me see that everyone is over there. Then only I'm going to start. Yes, yes, kids. That's really awesome. That's like HSP and Army, kids. That's like HSP and Army. Now, geometrical isomerism, kids, if I talk about geometrical isomerism, these are also known as what? What's another name? All geometrical isomers, they are known as diastereomers. 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 Now, what do you mean by diastereomers? Which are not mirror images of each other. What is the definition of diastereomers? Which are not mirror images of each other. Which are not mirror images of each other. So you have started from here. What are GI? Which compounds will show GI? We have always studied like this. Which compounds will show GI? What is the necessary condition? Tell us from there. You have started from diastereomers. Yeah. I'm going to start with this thing only. Now let's see. Do you think alkanes will show GI? Do you think alkenes will show GI? Do you think alkynes will show GI? Now, which will show GI? So let me tell you, my dear friends, these will never show GI, these will never show GI, and these may show GI, may. These may show GI, may. Now, why I'm talking about these may show GI? This will never show, that will never show. Alkenes may show GI. Along with alkenes, there are a number of other compounds also which may show GI. But yes, kids, those who are really there, they are going to get the best rank. Others, they are what to say. Anyways, let's see alkanes. There is no restricted rotation. There is single bond in between carbon and carbon. So free rotation is there. Free rotation is there. So one compound can convert into infinite forms. Alkenes and alkynes, they have got restricted rotation. They have restricted rotation. So who is responsible for restricted rotation? Due to pi bond. This is due to pi bond. Pi bond will not allow one form to convert into another form. But here in alkynes, it's been linear. So another form is not there. If I say this is R1, this is R2, it will always remain like this. So no another form. Now alkenes can show or cannot show. I would like to say alkenes, it is possible. It may be possible. Now let's see what is required over there. If I say this is alkene, and if I say this side is hydrogen, that side is methyl, and this side is hydrogen and that side is methyl. So in this world, there should be another compound which should look like this. Carbon, double bond carbon, this side hydrogen, that side methyl, that side hydrogen and this side methyl. Now see, both of these two compounds, they are butene. What I will say, if I say it's IUPAC name butene, then I would like to say that is also butene. Both of them are being butene. What's the difference? The difference only in the space arrangement. If I talk about the space arrangement in this compound, both the two hydrogens are being on the same side. I hope that, my dear students, everyone can see this. Both the hydrogens are on the same side, but in that compound, two hydrogens are being on different side. So one is 1,6, another one is being trans. People said cis and trans. If they would have given another name, Alia, Thalia, I would be teaching like Alia and Thalia like that. But my dear students, point to be noted, this is your sp2, sp2. Now remember on this sp2, if I say this is R1 and this is R2, they must be different. R1 and R2 must be what? Must be what? Say everyone, different. Not only this side, right hand side also, my dear students, right hand side also on sp2 hybridized, this is, if I say R3 and R4, they should also be different. If one side, this side and that side, both sides they are being different, I will say my double bond is active. Active for what? Active to show GI. My double bond is active to show GI. Mark my words categorically. Just keep in your brain that this is active. Thanusa, welcome, welcome. Now here also, so this is cis and that is trans. That means butene can exist in these two forms, and these two are having relation of GI. They are GI of each other. If I say there are two sisters, this sister's name is cis and that sister's name is trans. So they are sisters. Cis and trans are sisters. This is cis, that is trans. What relation they are having? They are sisters. So GI or diisomers, this is the relation. Cis and trans are the name. These are the names and the relation. That cis is the name cis-butene. I can say this compound's name is cis-butene. That compound's name is trans-butene. What's the relation they are holding? They are GI of each other. Are you getting my point, my dear students? We should be aware of the terms. If we are not aware of the terms, we won't be able to do anything. So we should be clear with the terms. Kids, if you are getting something, then why you are not showing green hearts? Kids, what are you doing, kids? Make the class like, yeah, bit full on energy, kids. That class should go on like this, full on energy, kids. Now, if I say that I am being provided with compound cis-but1, but1ene, but1ene, how I will write down but1ene? Just see, but1ene should be like this. Now you see this carbon which is attached with double bond or sp2 hybridized, the two hydrogens are same or different? They are same. Don't see on that side. If they are same, then this bond is dead. I would like to say this double bond is dead. Dead for what? Double bond is dead. Dead for what? Can't show GI. That means it can't show GI, and the double bond bit can't show GI. It's not stereo center. It's not a stereo center. Why I am talking about stereo center? That means it is not related with the GI. It can't show stereo isomerism. So here this was stereo center. This double bond we will say it's a stereo center. One stereo center. One stereo center. I hope everyone got it. What do you mean by stereo center? The double bond is a stereo center if it is active, and if it is not active, it will not be a stereo center. Everyone got it? Now, my dear students, now question arises that so if we are provided with a compound like this, see this side CS3, that side Cl, here C6H5, here it is ethyl. Now, my dear students, just where you have to focus, this is being sp2 hybridized. The attached two groups, they are different. On this side they are different. Go to that side, sp2 hybridized. Now these are same or different? These are also different. Now I will be calling this double bond to be active double bond, or I can say it is stereo center. Are you getting my point? This compound is having one stereo center. Now question arises, sir, it is cis or trans? My dear student, if you see this and that, they are not same. This and that, they are not same. That means no alkyl group is same. All four are different. Are you getting my point? All four are different. All four are different. That means cis and trans is not defined. Are you getting my point? Cis and trans is not defined for it. It's not defined. Then what type of? They will show GI. Will show 2 GI. But what will be the 2 GIs? Then definitely it will show ENZ type of GI. They will show ENZ. Now what is ENZ? I'm coming to that point. What is ENZ? Are you ready for that, kids? Show me fire in the chat section if you are ready for ENZ. Everyone, if you're ready for ENZ. Now remember that to understand ENZ, E stands for antigagon, and Z stands for Jusaman. Now what does it mean? Let me tell you, my dear students. If I say I'm provided with a compound C double bond C, it is attached with R1, it is attached with R2, attached with R3, attached with R4. And if I say out of these R1 and R2, this is senior, and out of R3 and R4, if it is senior. Now you see senior and senior both are on same side. These two seniors, they are on same side. If I say, just see, this is on lower side, that is also on lower side, both are on same side, then I will say it is Jusamen, Z configuration. If they are on different side, if they are like this, C double bond C, R1, R2, R4, R3. Now I have told you that this one is senior over here, that one is senior, they are on different sides, so they have become enemy. You can say enemy, E for enemy. You can take it like that, E for enemy, then E configuration. Now only the question arises that how to find out which one is senior, which one is junior. That is the question, kids. That is the burning question, sir. You have written this is senior, that is senior. How to find out? Right now, you have written R1, R2, R3, R4. How to get it? So there were three scientists, those who have given the rules to decide the seniority order. Are you ready to understand those rules? E for enemy, yeah. They are on different side. You can consider they are on different. They have become enemy, E for enemy. Now, three scientists. Seniority is decided by CIP rule. Seniority is decided by CIP rule. Now, what is the CIP rule? CIP. One scientist named as Kahan in gold, pre-log, but not interested in this name. Just remember CIP rule. CIP rule. CIP. We are interested only in initials. CIP rule. Let's see. These scientists. Rule number one. CIP rule number one. Are you ready for CIP rule number one? The atom alone or part of group directly attached to sp2 hybridized carbon with maximum atomic number, with maximum atomic number. Remember that. Mark my words, with maximum atomic number. Don't see the whole family, don't see the whole group, just one atom. You have to focus only on one atom. Remember that. Otherwise, you are going to do mistake. With maximum atomic number will be the senior most. Will be what? Senior most. For example, if I say kids, if I write down one compound, C double bond C, here chlorine, here hydrogen, here bromine, here hydrogen. First of all, see, this is cis because two hydrogens are same. This is cis. But if I talk about Ez, out of chlorine and hydrogen, this is having more atomic number. Hydrogen and bromine, this is having more atomic number. So senior and senior, they are on same side. So I will write down Z configuration. One person can have more than one names, but the person is one. So one compound can have more than one names. It is cis as well as Z. Compound is one, but it is having two names. Or I could have written one more compound, hydrogen, hydrogen, chlorine, bromine. Now see, it is trans as well as this senior is on this side, that senior on that side, enemy E. Now one question must be coming to your brain that sir, cis is Z and trans is E. No, there is no relation in between cis and trans. No, cis and Z or E or Z. It can be anything. Cis can be Z or cis can be E. I will give you examples also. Okay. Now kids, see. Let me give you another example. See, if I write down a compound like this, C double bond C, Cl, methyl, bromine, CH2, NH2. So C compounds out of carbon, carbon's atomic number is 6, chlorine's atomic number is 17. Who is senior? Definitely this is senior. Bromine and carbon, if you don't know the atomic number, no problem. As you go down in the periodic table, long form of periodic table, atomic number will increase. So this is senior. Now kids, do let me know that senior and senior, they are on same side, different side. Definitely they are on same side. So what should I write? E or Z? Its configuration will be E or Z. Definitely answer is Z configuration. Am I right, kids? How many of you got it? If yes, I want to see green hearts, green signal, kids. Everyone got it. Now CIP rule number 2. Let's move with CIP rule number 2. If first atom is not able to decide, then C, second atom, then C, second atom. If first atom is not able to decide, then C, the second atom. For example, if I write down one compound like this, C double bond C, CH2Br, CH2Cl, chlorine, CH2 iodine. Now, see kids, if I see this carbon, on this carbon, these two groups are attached. This is carbon, this is also carbon, they are same. Atomic number 6, 6, so tie is there. Now what you are supposed to do? Its second atom is bromine and its second atom is chlorine. Who is senior? This is senior. So we marked you are by senior. Hey my bro, you are senior. Now see over here, it is sp2 hybridized. Now this is chlorine and this is carbon. Don't see this, don't see this. Chlorine and carbon, this is senior. So senior and senior, they are on same side. What should I write down? It's Z configuration, Z configuration. Now none of them is being same, so cis trans is not defined. Cis trans is not defined. Kids got it? Do let me know everyone got it or not, kids. Fast, quickly do let me know. Till now it's clear to each and everyone. Now CIP rule number third CIP rule. Everyone ready for understanding it, kids? Do let me know. Everyone, just do let me know, kids. CIP rule number 3. It's in case of isotopes, in case of isotopes, the one with maximum mass will be senior. For example, if you see kids, C double bond C, hydrogen and tritium, carbon CH3, carbon CH314. Now you know that the atomic number is 1, but its mass is 3, its mass is 1. So this is senior. carbon, nothing is written, 12, and here 14. This is senior. Senior and senior on same side. So Z configuration. I hope this is clear. Is this much clear to all of you kids? Just to let me know, everyone. Hey, everyone, just to let me know. Till now it's clear. Now the fourth one, CIP rule number 4, is really a tough one. CIP rule number 4 is a tougher one. This is in case of multiple bonds, kids. In case of multiple bonds. Draw hypothetical structure. Now, it doesn't mean that you can draw anything. I will tell you the rules and regulations. Very good, kids. You are responding. Now I'm feeling bonded with you, kids. Now you're responding. That's really awesome. It should be like this only, kids. Then a teacher is feeling really awesome and he feel energetic, right, kids? Now, kids, if I say I'm provided with CHO, so first thing is that you should write down this compound properly. CH double bond O. Now there is one pi bond. This is going to play a game, pi bond. Now see, kids, how you are going to draw hypothetical structure. Just write down all the sigma bonds properly. I have written sigma bonds properly. Now I'm going to break this pi bond. You have to focus only pi bond. The pi bond is attached with whom? Definitely pi bond is attached with carbon as well as it is attached with oxygen. What I'm talking about, this pi bond is attached with carbon and oxygen. I have broken it. Now carbon was attached with oxygen. I have added oxygen, and oxygen was attached with carbon. I have added carbon. That's it. Now once you have to draw it, once you are getting proper revision of it, you can directly see, no need to draw it. See, kids, this carbon is looking to be attached with one oxygen, but one is sigma, one is pi. So finally what we see, the hypothetical structure, one carbon in the hypothetical structure, it is attached with how many oxygens? Carbon is attached with how many oxygens? 2 oxygen atoms, right? It was looking to be attached with one oxygen, looking with one oxygen, but in the hypothetical structure it is actually attached with 2 oxygens. How many of you got it? How many of you got it? Now same thing I can draw for cyanide. Just see, more clarity will be there. Cyanide is there. Write down properly valency wise, C triple bond N. Now 1 sigma and 2 pi bonds. Can you see 1 sigma, 2 pi bonds? Now if I am going to draw hypothetical structure, I will write down sigma bond simply like this. How many pi bonds I am going to break? I am going to break 2 pi bonds. Now carbon was attached to nitrogen. I have added nitrogen. I have added carbon. Now in cyanide it's looking to be attached with one nitrogen only. It is looking to be attached with one nitrogen, but it is finally attached with 1, 2, 3 nitrogens. One carbon is attached with 3 nitrogens, right, kids? Everyone. Now no need to draw hypothetical structure if you know this. So carbon 3 bonds. If it is attached with 3 bonds, so 3 nitrogens. Now, if you got it, then if I write down carboxylic acid, COOH, only what you are supposed to do, C double bond OOH. Now you see, no need to draw hypothetical structure. 1, 2, 3. Carbon is attached with how many oxygen? Kids, do let me know. If you are really able to understand one carbon is attached with how many oxygen atoms, do let me know in the chat section. 3. So how to apply it? See, if by chance they have given a compound like this, now tell me it is E or Z. Everyone do let me know. Let me have a sip of water. Till that time, do let me know it is E or Z. I want to see the answer in the chats. Fast, quick kids, quick. Do let me know E or Z. E. 11 is writing E. Let me check it out. Now kids, this is carbon. Don't take it as a COH. Don't do that mistake. Atomic number 6, this is higher. So this is senior. Now this carbon, that is also carbon tie. This is attached with 2 nitrogens, and that is looking with 1 but actually attached with 3. This is senior. Senior and senior, they are opposite. So E configuration. Very good, 11. Your answer is absolutely correct. I hope everyone got it. I hope that everyone got it. Everyone. Now see, if I give you a tough question, if they are going to give rank deciding question, now what should be the configuration? So see kids, right hand side, this is carbon, further attached with carbon, but this is winner, oxygen is senior. Now here this is nitrogen, this is carbon, this is 7, this is 6, this is senior. I hope everyone got it. Senior, same side, Z configuration. Is it clear to each and every one of you? Z is coming or not? E. People, you have done some mistake. You have done some mistake. See, carbon and then oxygen. Its senior most is oxygen, atomic number 8. It is having 2 oxygen, but after 2 carbons. After 2 carbons. It's carbon, carbon tie, and after carbon there are carbon, but here is oxygen. Everyone clear? Is it clear? Is it clear or not? Do let me know, kids. Is it clear or not? Everyone, just do let me know. Is it clear or not? Have you got it or not? Are bhai, just do let me know. It's Romba Sulubham or not? If yes, green hearts, green leaves, kids. Yes. Now, CIP rule number 5. Hey, HSP, wow. HSP is over here, kids. Now, now, CIP rule number, tell me CIP rule number 5. Bond pair is senior to lone pair. Remember that. Bond pair is senior to lone pair. That's it. Bond pair is senior to lone pair. What is it? What's the meaning of this? Let's see, kids. If I write down C double bond N O H H CH3. Now see, kids. Here out of these, this is senior. Now this is bond and this is a lone pair. So bond pair is senior. Anything it is attached senior. Senior and senior opposite. So this is E configuration. Later on I will tell you it is syn also. It is known as, its another name is syn also, that I will tell you later on. Syn aldoxin. That I will let you know later on, right? This much is clear to all of you. Now the next thing comes, that how to find out total number of GI. If you are having more than one double bond, how to find out total number of GI. But if you are ready for that, I want to see green hearts along with fire in the chat section. Everyone, if you are ready with that, kids, you are really going to get rank because you are dedicated kids. It's your consistency, it's your the high willpower that is only going to give you the best rank. Now see, kids. Calculation of total number of GI. Calculation of total number of GI. I will call it Tangi. What I will say in shortcut, Tangi. Total number of GI. Tangi. Total number of GI. Now case 1. Case number 1. When terminal atoms or groups are different. So terminal atoms or groups are different. I will explain what are terminal atoms or groups. Now, active double bonds can be active double bonds. Number can be even or odd, doesn't matter. Even or odd, that doesn't matter. Now, Tangi will be total number of GI will be equal to 2 raised to power n, where n is number of stereocenters. What are stereocenters? We can say total number of active double bonds, or I can say, I can write down n is equal to total number of active double bonds. Now let's explain, otherwise you won't be able to understand, kids. So let me explain. Are you ready, kids? I'm going to explain it, okay? See. If I'm writing a compound like this, CH3H, C double bond, CH, CH double bond, CH, C2H5. Now see, kids. Everyone just focus. This carbon is sp2 hybridized and these two are different. First of all, see, these two are different. This one and this one, they are different. Now this carbon, one is hydrogen, another one is so long group, they are also different. So I will say this is active. First stereocenter I have got. Now come to this double bond. This is sp2. One is a hydrogen, another one is ethyl. They are different. Yes, they are different. Now on this carbon, this is also sp2 hybridized. One is hydrogen, another one is this group different. So this is also active. This thing we have got it that it is having two active double bonds. But what is R1 and what is R2? Let's see. Let's decide that also, kids. It is showing from here to here. This is the environment, right? It is showing GI. Now what is left? This side, methyl is left. I can write down this compound like this is methyl. I can write down it properly so that everyone can understand it. In this way, I can write it down. Now see, from here to here, it is showing GI. Can you see? Now, one is R1, another one is R2. Just see if I say this is R1 and that is R2. They are same or different. Whatever is left other than the atmosphere which was responsible for showing GI, that is R1 and R2. They are different. If I say this one is R1 and that one is R2, they are same or different? Different. So R1 is not equal to R2. I can say total number of GI Tangi, total number of GI is equal to 2 raised to power 2, that is 4. I have got answer. This compound will show 4 GI. Now, formula always increases the speed, but formula never gives us the information that is fundamentally correct. If you want to understand fundamentally what are the possibilities, see this double bond. Let me go with the visualization. Visualization part says that this double bond, it can be cis, it can be cis. How many possibilities? That cis, this cis, that trans, this is also trans, this is cis, this is trans, this is trans, this is C. How many possibilities are there, kids, that this compound can exist? This compound can exist in 4 types. These are the 4 types of GI. This is the visualization part. I hope that everyone got it, kids. Everyone got it, kids? Do let me know. Wow, some people are writing the answer also. Very good, kids. Now see another one. If I give you a compound like this, Cl, CH double bond CH, CH double bond CH, and CH2, CH double bond CH2. Actually, this compound is having 3 double bonds. But out of 3 double bonds, how many double bonds are being active? Very good, kids. Very good. You are really awesome. Chaitanya, Rising, 11, Chaitra, fantastic, kids. Out of 3 double bond, how many are active? So definitely you will say, so this is active and this is active. That is dead. Can you see? This is dead. Who made it dead? These 2 hydrogens are same atom, so it is dead. It's not a stereocenter. So it is showing GI from this to that, this to that, this to this only. So who is R1 and who is R2? I would like to say this one left is R1 and that much part left is R2. Are they same or different? My dear students, definitely R1 is different from R2. They are not same. If R1 is not equal to R2, definitely Tangi will be, total number of GI will be 2 raised to power 2. Once again, 4. Everyone got it? Very good. People are writing last one is dead. That's really awesome. So now suppose why formula is given, kids. Let me tell you. What is the use of formula? Why people made formula. Now you will get to know. Now, how many active double bonds are there, kids? Definitely write down in the chat. 3 active double bonds are there. Can you see, kids? Now this one is R1 and that is R2. They are not same. They are different. R1 is not equal to R2. So total number of GI Tangi will be equal to total number of stereocenters are 3, 2 raised to power 3. That is 8. If you want to go with the visualization, if you want to visualize it, you can see, my dear students, it will take too much time. Cis, trans, cis, trans, cis, trans, cis, trans. How many? 1, 2, 3, 4, 5, 6, 7, 8. You got it? So formula always increases the speed. Never it is going to teach us, never it is going to go with the fundamentally what is right, what always it deals with the speed. So, okay, Hamad is there. Okay, very good. Hamad, welcome. Now, kids, case number 2. Let's deal with case number 2. Let's come to the case number 2. If R1 is equal to R2, if R1 is equal to R2, case 2, it will be case 2. If R1 is equal to R2, then total number of GI will be 2 raised to power n minus 1 plus 2 raised to power p minus 1. Now what is p? Another term, another variable is there, that is being p. Now let's find out what is being p. So two cases are there. Subcase x and subcase y. If the value of n is equal to even, if the value n is equal to odd, there in case number 1 it was not going to make any difference, but here it will matter a lot. Let's see. If I write down a compound like this, CH3, CH double bond CH, CH double bond CH, and CH3. Now see, it is also having 2 active double bonds. What you can see, R1 is same as R2. Can you see, kids? R1 and R2 are same. Is it visible? This is R1, that is R2. R1 and R2 are same. So total number of GI. Now here P will be equal to, in this case, P is equal to n plus 1. Now apply maths. If you know maths, do apply the formula. Total number of GI will be equal to 2 raised to power 2 minus 1 plus 2 raised to power n plus 1 by 2. P is equal to n plus 1. N plus 1. Yes. N is how much? 2. 2 plus 1 will come 3. Okay. P is equal to n plus 1. N is equal to how much? 2 plus 1, 3. I think something is missing. Something is missing, kids. Something is missing. P is equal to not n plus 1. P will be equal to n by 2. Because its answer will come, I know that. Its answer will come out to be C, C, T, T, C, T, CT and TC will be same. Now see kids, 1, these two are identical, so 2 and this 3. Now you see kids, answer is 3. Now what's the benefit of visualization? Can you see the benefit of visualization? I've forgotten the formula. What is P? I've forgotten the formula. What is P? Now who is going to help me? If I've forgotten the formula, what is P, then who has helped me? The formula or the visualization? Tell me kids. First of all, do let me know who has helped me right now. The formula or the visualization? I want to see the answer in the chat kids. Everyone, I want to know the answer in the chat. Who has helped me right now? The visualization, fundamental or the formula? Do let me know in the chat section. Who has helped me kids? So here P is equal to n by 2. P is equal to n by 2. So n is equal to 2. So 2 raised to power 2 by 2 minus 1. So it is coming out 2, and that 2 raised to power 0 is 1. So the answer is 3. Can you see kids? Everyone, that's why I'm always telling you, go with the fundamentals. Never rely on the formula kids. Thank you, Chaitanya. Thank you. Thank you. Now see kids, this one, if I say this one, CH3, CH double bond CH, CH double bond CH, CH double bond CH and CH3. You see the atmosphere from here to here, and R1 and R2 are same, and it is 3. So here P is equal to n plus 1 by 2. There it was n by 2, there it is n plus 1 by 2. Now apply formula. Tangi is equal to 2 raised to power 3 minus 1 plus 2 raised to power 3 plus 1 divided by 2 minus 1. So it will come out 2 raised to power 2 plus 4 by 2, 2 minus 1, 2 raised to power 1, 6. Everyone got it? Is it clear kids? Is it clear to all of you kids? Do let me know, is it clear to each and every one of you? Do let me know kids. Is it clear to each and every one of you or not kids? I want to see in the chat that everyone is able to understand it or not kids. Do let me know. So always show green signal once you are able to get it kids. Now this is over and out. Now let me tell you GI in cycloalkanes. It's not only that GI is in alkenes, that it's not necessary that double bond should be present to show GI. Without double bond also GI is possible. Now let's see GI in cycloalkanes. GI in cycloalkanes. Suppose if I say that I am provided with cyclobutane, and this cyclobutane is attached with two methyls. Now can you visualize this compound kids? That I am provided with a book, and that book is like this. If I say it is attached with two bonds like going up, and this one is also going up, both of them are going up. Can you see? Now they are on same side. This is cyclobutane, this compound, same side 2 methyl cis. I can put it like this, then also same compound cis. If it is going down, then also cis. If it is going right, then also cis. Going left, then also cis. Anyways, I have can written. I can write it. It can be written in any way. Now, if one methyl is going up, another methyl is going down, they are opposite. I would like to say they are trans. Now also they are trans. Now also they are trans. Now also they are trans. The trans one will always remain trans, and the cis one is always remaining to be cis. So what's the relation they are having? Definitely they are GI of each other. I hope that I made myself very clear. Now see, this is both the methyls are going up. So we can say they are on same side. So it is cis. And if I draw it like this, kids, one methyl is going up, another methyl is going down. So they are opposite side, up, down. That is being trans. What relation they are having? They are GI of each other. GI. Now this compound could be written like this. They can write down this compound in this way also. That's two methyls are coming towards observer side. This is known as wedge. Coming towards observer side means coming towards your side. So the two methyls, they are on same side. They are identical. Or they could have written it like this. This methyl is going away, dash, dash, dash. This is dash. Both the two methyls are going away. All three are identical. What I will say, kids, if I say this is X, this is Y, this is Z, what's the relation in between X, Y, Z? They are identical, no relation. They are same. Now, this compound could be written like this. One methyl is going towards observed side, means coming towards your side, and the methyl is going away from you. They could have written like this. So these two are identical, but this side with that side, they are having relation of GI. Kids got it? This means towards observer side, this means away. Going away from observer, written with the dash. Coming towards observer, this is known as wedge. Wedge, WDG, wedge. It's clear to all of you? Is it clear? But by chance, examiner is giving tough question. So remember about cyclohexane. Now I am going to deal with cyclohexane. Sometimes they can give you tough question. Let's say in cyclohexane. Simply if I write cyclohexane like this, both the methyls are on same side. So this is cis. Both the methyls are on opposite side. I will say it is trans. I will say it is trans, cis and trans. But see, kids, if they're going to give you tough questions, so remember that I'm going to draw chair form. Now see, this is known as chair form, because in one go you won't be able to understand. So pay proper attention, kids. You won't be able to understand in one go. How many, this vertex is going upside or downside? Upside. This vertex is going downside, right? Up, down. This is going down, and that one is going upside. Till now it's okay. Till now it's okay. Now to this carbon, two valencies are attached. Two valencies attached. One is going with the axis and one is going other side. One is going with the axis. One is going with the axis, another one is going like this. If the vertex was going up, this is also going up, this is also going up, and this will be known as axial bond. Axial. If I say here methyl is attached, this is going up, this is also going up, then this is known as equatorial. This is going down. Now if I say this axis is, this vertex is going down, so this axial will go down and equatorial will go up. This is axial will go down. If I say hydrogen, then equatorial will go up. Equatorial will go up. Now this is up, this is up, they are cis. I hope you are not able to understand. I hope that you people are not able to understand. Let me tell you once again. See, let me draw a chair. Just try to understand. Just focus what I'm saying. Just focus. This vortex is going up. This rocket is going up. And this rocket is going down. Till now it's okay. This I'm talking about rank deciding question. Up and down is clear. One rocket is going upside, another rocket is going downside. Clear, kids? Everyone, this much is clear. Now with this carbon, two valencies are added. One is going like this, another one, they will make V. Understand, they will make V. Tetrahedral always make story of two V's. They are at 109 degree. Now if this vertex is going up, then it's this bond that is known as axial, that is also up. That is also up. Axial is up, equatorial is down. Now if I say axis, the vertex is going down, then definitely its rocket is going down, then axial bond will go down only, down, and equatorial will go up. Now if by chance somebody has added one methyl over here and one methyl over here, then do let me know what will you say. This is cis or trans? Do let me know. What will you say? If the examiner has given question like this, what will you call it? This is cis or trans? Do let me know in the chat. So this is going up, this is going down. This is trans, but examiner will not write down which one is going up, which one is going down. How he will write down, how he will give the question, let's see. He will give you a question like this. What is the relation in between x and y? This is x and that is being y. What is the relation in between x and y? That is the question. Find out relation in between x and y. Now, how will you do this question? You have to find out whether they are cis or trans. Let's see, kids. Now, this one is going up, axial. Axial is going up. I got about this. This is going down. So this is axial going down. If axial is going down, then this is up. Up and up. This is cis. Now here, this is going up. Axial is going up. If axial is going up, equatorial is going down. This methyl is going down. This is going down. Axial is going down. So methyl is equatorial going up. So this methyl is down, that is up. Opposite side, opposite side. So trans. So definitely they are GI. The relation in between X and Y are GI of each other. I hope everyone got it. This is rank deciding question. If they are going to ask for top 10, top 50, that is Ian's tally, then they are going to give such type of question. Do let me know, kids. Is it clear? If not clear, I will tell you 100 times. I will tell you again and again, but just do let me know if it is clear or not. If yes, I want to see some fire along with green hearts. If not clear, you can write down not clear. Everyone just do let me know. Fast, fast, kids. And smash the like button also, kids. Hit the like button till now if you have not done so. Kids, fast, fast. Those who have not smashed the like button, do that. Yeah, now let's move towards GI in cycloalkenes. Now GI in cycloalkenes. Cycloalkenes up to 7-membered remains in cis form only. Therefore, do not show GI. With respect to double bond. Now, what is the meaning of this with respect to double bond, kids? With respect to double bond means a lot. For example, if I say that I'm provided with cyclobutene, then its bond is going that side. That means hydrogen is going right hand side, bond is going this side, hydrogen is, this will remain in cis form. Its trans is not possible because of angle strain. If I say cyclohexene, if I am having, so this bond is going that side, hydrogen this side, this side, hydrogen cis form. They will remain in cis form only. They can't show GI with respect to double bond. But what is the meaning of with respect to double bond? Let's see to it. With respect to double bond, what is the meaning of that, kids? See how the question will come in your examination. Which will show GI. Which will show GI. Now they will give you compounds like this: 1, 2, 3, 4. A, B, C, D. A like this, B like this, C like this, D like this. Now what's your answer, kids? What should be your answer? I want to know. Just in the chats, do let me know what should be the answer, kids. Fast, fast. Move it, do it speedily, kids. Do it speedily, everyone. I'm waiting for your answer, kids. Bao is waiting for your answer, kids. Everyone just do let me know. Speedily. D, yes. That is the correct answer, kids. This is being the correct answer. Now see, both the two methyls over here dead. Dead. This is also dead. That double bond is also dead. All of these are being dead. But how it will show? Just see. This compound will exist in two forms. Methyl up, cis. One methyl up, one methyl down, trans. With respect to substituted cycloalkane, these are the two forms, cis and trans. And that's why it will show GI. Kids got it? Everyone got it? Just to let me know, everyone. Clear? Fundamentally, everything clear, kids? Okay, Sashank. Fantastic. Gets everyone clear. Now, let's see. GI in alkenes. GI in alkenes. Have you ever thought of alkenes? Do you know anything about alkenes? What do you mean by alkenes? GI in alkenes. So be aware of alkenes, kids. What are alkenes? Not aliens. Alkenes. C double bond C double bond C. Continuous double bonds. Or I can write C double bond C double bond C double bond C. Both of them are alkenes. Now, my dear friends, if I write down here CH3, here hydrogen, these two are different. If I write down here CH3, here hydrogen, these two are also different. But number of pi bonds are even. They can't show GI. Now you will ask why, sir? I will explain. Can't show GI. Can't show GI. But if the compound is given like this, CH3H, they are different. CH3H, these are also different. But here the number of pi bonds is 1, 2, 3, odd. There it was even number of pi bonds. Here we are having odd number of pi bonds. Now it will show GI, this will show GI, will show GI, it will show GI. Now you must be thinking, why sir, they are looking like same, they are exactly same, then why one is showing GI, another one is not showing GI? So remember that these terminal atoms or groups, the one which is attached with sp2 hybridized, see, this is sp2, this is sp2, but middle one is sp, this is sp2, this is sp2, the middle ones are sp. So first thing is that the atoms or groups which are attached on sp2 hybridized carbon must be different, and the number of pi bonds must be odd. If you by chance forgetting, then remember God. Just remember God. To show GI, number of pi bonds must be odd. When nothing is visible, everything is looking like dark, then at that time you should remember about God. Number of pi bonds should be odd, then it will show GI. Now my dear students, what is the reason for it? Let me explain. If you want to know the reason or the details. Actually, whenever there are even number of double bonds, this is one valency is coming towards observer side, one valency is coming towards observer side, and one is going away from observer. But if we talk about here, they are in the plane of paper only, nothing is going away or towards, they are in the vertical one. Now you will ask, sir, how to understand, how to visualize? Just see kids, if I say this is lying horizontally, this is lying horizontally, it is placed horizontally. Now you remember that when it is horizontal, then the pi bond must be vertical. The pi bond must be vertical. The pi bond is vertical, kids, right? So it is forming a bond with this carbon. They must be attached vertically, vertical, right? Vertical bonding. Now this is attached with one more pi bond, that should be horizontal. If this is horizontal, this has to be horizontal, and these are horizontal, kids, horizontal, then the sigma bond one must be vertical. It must be vertical, kids. It's vertical. That means if I say this is in the plane, but this is going up and down, they are not in the same plane, then how the two methyls can be on the same side or can be different side? They will be. If I say this is methyl, this is hydrogen, methyl is going vertically up, this will always remain on the same distance from these two. Can't show GI, can't show GI. Are you getting my point? Can't show GI, can never show GI, can't show GI. So what you have got from here, that to show GI, the atoms must remain in same plane. To show GI, atoms or groups must lie in same plane. Am I right, kids? Must be present in same plane. Kids, got it? Now if I draw the odd one, see odd one, see if this is lying horizontally, if I say this is lying horizontally, then the pi bond will go vertically. If this is going vertically, then another pi bond will go horizontally. If this is going horizontally, then another pi bond will go vertically. And if it is going vertically, then once again they will lie horizontally. Then they are in same plane. I hope kids got it. Will show GI. This will show GI. Kids got it. The visualization is clear. Everyone, you are liking it. Everything is perfect. Everything is perfect or not, kids? Everyone, I want to know that you are able to understand or not. You are getting it or not? Got it. So I have told you each and everything about GI, right? Now we are going towards optical isomerism. But before, everyone just to let me know, are you ready for optical isomerism? Are you ready? Clear, kids. GI is completed, done and dusted. Are you ready for optical isomerism, kids? Should we move towards optical isomerism? I want to see fire in the chat section if you are ready for optical isomerism. Now, very good, kids. Fantastic. Now, see. Before we move towards optical isomerism, there are few questions. Would you like to go with these questions? I brought few questions. I'm here with few questions. Yes, yes. So, what's the answer of this question? I would like to see in the chat section what's the answer of this question, kids. Yes, kids. Fast. The alkene that exhibit geometrical isomerism. Speedily, kids, give the answer speedily. Some are going with C, 3B, some are going with B also. Let's see what's the correct answer. B is the correct answer. 2-methylpropene, its bond is dead. Its bond is dead. Let's explain 2-methylpropene, how it is dead. How to write down propene? 1, 2, 3. This is methyl. Now see, these two are same and the hydrogens are same. This is dead. Now this is the A case. If you want to see C case, 2-methylbutene, 1, 2, 3, 4. Butene and 1, 2, 2-methyl. Now see, these two are methyl. They are same. So it's also dead. Dead. Can't show GI. Propene. If I make propene, then you see it was simple question. Dead. Easy kill question or not, kids? It was easy kill or not? Do let me know easy kill. Now, next question. Once again, let's go with this question, kids. Let's see who is going to give the correct answer for this question. I'm waiting for your answer, kids. Yes, kids. Fast, fast, kids. D. One kid is writing D. Let me see what answer is given. Wow. So both A and C. So why 1,2-dibromopropene? 1,2-dibromopropene. This A1 is, propene is like this. 1, 2, 1, 2 dibromopropene. So here should be hydrogen and here is methyl. Can you see? This is active. They are different. These are different. C. C is 2,3-dibromobutene. Butene 1, 2, 3, 4. Butene. Let's do the numbering. 1, 2, 3, 4. 2, 3-dibromo. Here also bromine is there. Here also bromine is there. So this is methyl. That is also methyl. So this double bond is active. Everyone got it? I hope this is also clear to each and every one of you. Next question. Geometrical isomerism not shown by. These are all the questions which have been asked. Previous year questions. All these are being previous year questions, kids. What's your answer, kids? Do let me know. What's your answer? Hey everyone, just do let me know. What's your answer? Fast, 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 kids, fast. Your speed is less. I want quick response for the questions. D. Rising star is going with D. Let's jump out. Tell me the answer. Oh, C is the correct answer. Not shown by. I think you have not seen not shown by. Not shown by. Let's see. This is C. Both the two hydrogens are same. Two hydrogens are same. So this double bond has become dead. Dead. Can't show GI. You have not seen not shown by. Right. Another question. Wow. Wow, kids, wow. Yes. What's the answer? Everyone just to let me know. What's the answer? B. Same. Let's see. B. Wow. Now see, these two are on the same carbon. So it is dead. Here it is dead. But see, this is R1 and this is R2. Different. R1, R2 different. And this is R1 and this is R2. They are also different. So this double bond is active. 1 stereocenter. Fantastic, kids. Next question. Tell me the answer of this question. Fantastic moving, kids. You are doing really a stupendous job. Baba is feeling fully accomplished with your response. Kids, do let me know what's the answer. Fast. A. A, let's see. A, wow. How many stereogenic centers? Stereocenters or stereogenic centers in this compound? This is 1. You got it? I have gone through it. I taught you everything. Oh, this is dead. So 0. This is not stereocenter. See, they have written methyl. This is also methyl. That is also methyl. This is same. So this is dead. So 0. No stereocenters there, right? Next. Everyone gets fast. I want to see your answer, kids. Speedily. Fast, kids. What's your answer? The alkene that will exhibit geometrical isomerism is. It's very simple, kids. C is the correct answer. C. Very good. Next. Wow, that is really a fantastic question. This one is a good question, kids. Let's see who is going to give the correct answer for this question, kids. Everyone is going with C. Once again, C. C can't be the answer for this. I don't think C. C is wrong. Definitely C is going to be wrong for this. D should be the answer. Now see, if you see the C, this is R1, this is R2, and they are same. This one is same. So this is dead. Can't show GI. But here if you see, this is CH2, this is CH2, here this is CH2, but this is CH3. Different, and they are also different. They are different, this is different, so it will show its double bond is active, kids. I hope that everyone is getting. Now another one is not shown by. Remember that not is written, kids. Not. Focus on not. Acha, Chaitanya, you are right. There is a lag in the chat. You are not wrong. Thank you, Chaitanya. Thank you. Salute. Salute, Chaitanya. Now, what's the answer of this question, kids? Do let me know. A. Let's see. Kids, you are able to do all the questions. Now, I am not going to teach. You can ask for better teacher. You are able to give all the questions. How you are doing it, kids? You are doing all the questions in the perfect manner, kids. How you are doing all the questions? I am unable to understand. Now, we will deal with questions later on. Now, let's move to optical isomerism. The rest of the questions, or should we deal with questions? You want to do more questions? Kids, do let me know. Or should I give you for homework? Now, this is a really awesome question, kids. This is really awesome. Very good questions. So, we will go with the questions. These questions will boost your knowledge. They will tell you how much. Oh my God, 11, 11. Thank you, thank you. Salute, salute. Now, what's the answer of this question, kids? Questions you want. Okay. So, do this question. What's the answer of this question? Do let me know in the chat. Fourth, let's see. It's second. How many geometrical isomers are possible for given compound? Now, this is active. Active or not? Active, yes, of course, this is active. Now, this is dead. This double bond is dead. But this R1 and this take at R2 substituted cycloalkane. Can you see this is R1 attached with this cycle and this is R2. So this ring is one stereocenter. This ring is also a stereocenter. Are you getting my point? This ring is also acting as stereocenter, but this is sp2 hybridized, can't act as stereocenter. So only this one. So this can't act as stereocenter because this is sp2 hybridized. If this would have been attached somewhere else, this would have been. So only one stereocenter, so 2 GI. Got it, kids? Any doubt? Everyone got it? If you got it, बी कैसे हुआ? बी देखो ये डेड हो गया ना. दिस साइकिल इज ऑफ 6 मेंबर्ड एंड 6 मेंबर्ड साइकिल with respect to double bond, this double bond is dead. Got it? Is it clear, kids? Got it? So it will not be 4. Everyone, is it clear? Do let me know in the chat section. ये वाला समझ आया कि नहीं आया? Let me tell you, kids. See, I taught you cycloalkene up to 6 membered, they will always remain in one form only. Their double bond is dead. This is dead only, this is active. So 2 raised to power 1 is 2. 2 should be the answer. Now you got it. It can't be 4 because double bond in cyclohexene is dead. If this methyl would have been attached on this carbon, then this could be the stereocenter, but it is attached with sp2 hybridized, so can't act as stereocenter. I hope you got it. Everyone got it? Everyone got it? Now, this one. This is really good question. All the questions are really awesome, kids. Fantabulous questions. Do let me know. What's the answer? Yes. Everyone just to let me know. Answer of this question I want to see, kids. Second. Let's see. Wow, second is correct. All they are on same side. All on same side. Now 2 same side, 1 is going away. Nothing else is possible. These are the only 2 possibilities this compound can exist. Very good, kids. Really awesome. Now, this one is a really awesome question, kids. Fast. What's the answer of this part? Now, this time you can hit this question. It's easy peasy lemon squeezy. You can do it, kids. 1. People are going with D, some are going with 1. Let's see. 4th is the correct answer. Now see, kids, this is active and this is also active. Now 2 are being active, so total number of GI Tangi will be equal to 2 raised to power 2. That is 4. This time 4 is the correct answer. I hope everyone got it. I hope everyone got it. Now this one. Nice questions, kids. Really, it's looking like we have done a hard work. Hard work. Good result we are getting, kids. One A. Let's see. Oh, kids, this is D. This is D. See, kids, this is methyl and this is also methyl. R1 and R2 are same or different in this case. R1 is equal to R2. So case number 2. Today only I taught you. So it will have 3. CC, TT, and CT and CT and TC, they were identical. Do you remember? One, they were identical. Two, and this was third one. So for this, three. Now this is methyl, that is chlorine, that is different. R1 is not equal to R2. Their R1 and R2 are same. So 4, this is a really awesome question. I taught you or not, kids? Do let me know. Taught you or not, kids? Do let me know. In today's class, I have given you information about it or not, kids? Do let me know. Now, this is awesome question, kids. Awesome. Once again, good question, I would like to say. Yes, kids. What's the answer? Kids, once you are liking it, once you are loving it, don't forget to show green hearts, green signal, green leaves, anything green. That indicates that everyone is able to understand, right, kids? D. Okay, let's see. Wow, kids, you are really rocking, kids. I don't think anyone is in need of explanation to this. Now this one. Wow, kids, obedient kids, consistent, obedient. Really awesome. Now what's the answer of this part, kids? What's the answer? D. This time people are going with D. Let's see. Wow, kids, wow. Awesome, awesome. I am feeling awesome. Not only you, even your teacher is feeling awesome, kids. You have done it. You have done it. Wow. You have made my day, kids. Now, optical isomerism. We are going to deal with optical isomerism. But kids, put your likes and share it to all the kids. Class is still have to go, the show must move on, kids. But if you are having your friends and those who have not, smash the like button, kids. Make it, smash it. Let me see what's the score right now. What's the score? 234. Try to make it 250, kids. Can it go up to 250? Can it go up to 250? Now, let me deal with Now, optical isomerism will take time and it will need visualization also. So, kids, are you prepared for optical isomerism? Just to let me know. Break 20 to 38. I will give one break after. Okay, so let's take 15 minutes break. Okay, then we will start optical isomerism. You can charge yourself, everyone. 15 minutes break. Optical isomerism. We will start after the break. So till right now it's 10:40. So let's meet at okay, kids, right? The calculation is correct. Up Chaitanya now, so just enjoy. It's short break. Okay, Chaitanya, take. Yeah, I'm from Avengers, right? Take break. Kids, are you back? Is everyone back, kids? So let's it go. If everyone is back, kids, I want to see some fire in the chat section. Now see, kids, to show optical isomerism, we will take light. This is experimental setup. This light is multi-directional light. Ordinary light that is being multi-directional. What I will say, it's being multi-directional light. Now this multi-directional light, if this is passed through Nicol prism, which prism? Nicol. This is made up of calcium carbonate. That's why it is known as calcite. Calcite, made up of calcium carbonate. Once this light is passing through Nicol prism, this light will become plane polarized light. This will become unidirectional, kids. What I'm saying, try to understand what I'm saying. This light will become unidirectional. It will move only in one direction. It will move only in one direction, not the multi-directional. It is just unidirectional. Unidirectional, kids. It will become unidirectional. And this light, the one which is unidirectional, this is also known as what? This light is also known as plane polarized light. Plane polarized light. Now this light will be passed through the solution. The solution which is under investigation. The solution which we are going to find out, that solution will be filled in one tube. This will be one tube, and this tube will be containing that organic solution. Now we have to find out this organic solution is optically active or optically inactive when this light is going to pass through this organic solution, right? Now, if the compound is optically active, if the compound is optically active, then the light will get deflected. As this light was moving, this light was plane polarized light, which we have seen. If this light is coming in the same direction, then number of things are possible. But if the light is found to be rotated, then two possibilities are there. The light will move either in clockwise direction from the normal. It's being found to be rotated clockwise direction. Who is rotating the light? Organic compound. How will be rotating? If it is found to be optically active. If the light is plane polarized light is found to be rotating clockwise direction, then the compound will be known as dextrorotatory. we can say plus sign with, or we can write down small d also, dextrorotatory plus or small d. If the light is found to be rotated anti-clockwise direction, if it is found to be rotating in anti-clockwise direction, then the compound will be known as laboratory minus or small l, small d, right? Yes, hence, yes. Now, see, this whole setup, is there anyone who is going to tell me this whole setup is known by the name? This whole setup is known as spectrophotometer. Say everyone, spectrophotometer, or another name is polarimeter. Polarimeter, two names. This whole setup is known as spectrophotometer or polarimeter. Is it clear, kids? Everyone say. This whole setup is known as what? Spectrophotometer. Medal, Bandurazu. Energy, my energy is full on. Everyone say this whole setup is known as spectrophotometer or polarimeter. Everyone, I want to see. Now, how much light is getting rotated, that depends on number of things. The wavelength of the light used, the nature of the solute, the organic compound, nature of solvent, temperature, number of things. Now see, kids, we are neither having the compound nor we are having what? Nor we are having spectrophotometer. So scientists, what they did, they have done they made some theoretical portion just to find out whether the compound is optically active or not, right? Now, theoretically, how to find out compound is optically active or not? So, theoretically, we have to give, and in the paper, in the question paper, theoretically, you will get something, right? There should be neither the organic compound nor the spectrophotometer. Everything will go theoretically. So theoretically, we can say for a compound to be optically active, for a compound to be optically active, compound shouldn't have plane of symmetry, pos, center of symmetry. It should neither have plane of symmetry nor it should have center of symmetry. Secant pos means plane of symmetry, cost means center of symmetry. Now kids, if I talk about, this is 99% important for your syllabus. This is just 1%. So our focus will be mainly on plane of symmetry. If we go on the higher level, then they say that alternating axis of symmetry also, they talk about axis of symmetry, but we are not going to deal with. We have to understand plane of symmetry only. That means these two things are not there, then the compound will be known as asymmetric compound. That compound should be asymmetric, or the compound must be chiral. I'm not talking about chiral carbon. I'm talking about compound should be chiral. Now we have to focus. We have to focus, kids. that plane of symmetry. Now we are going to deal with plane of symmetry. How to find out plane of symmetry, kids? Plane of symmetry is an imaginary plane. An imaginary plane which divides the compound the whole compound in two equal parts. So that one part looks like mirror image of second part. Now kids, let me explain this plane of symmetry. Let me give you some examples. Now, let me give you examples for this. Thank you, kids, thank you. Thank you, kids. Now see, kids, if I say that I have drawn A, do you think it is having plane of symmetry, kids? Do you think it is having plane of symmetry? Yes, the plane of symmetry is like this. And remember that few words we have to understand. This is known as vertical plane of symmetry. We will say vertical plane of symmetry. It is vertical plane of symmetry, everyone. Vertical pause is there. Now if I write down a compound like this, now do you think there is plane of symmetry? This is a horizontal plane of symmetry. Can you see, kids? Horizontal plane of symmetry. Vertical plane of symmetry, horizontal plane of symmetry. Now these are the, everyone, are you getting my point, kids? Everyone, are you getting my point? These are having plane of symmetry. Now see in the compound, let's see. Let me write down few compounds. If I write down compounds like CH4, CH3Cl, CH2Clbr, CH chlorine, bromine, iodine. How many compounds I have written, kids? 1, 2, 3, and 4. Now, my dear students, let me try to explain each and everything. So, if I say, right now I am not having valencies. Okay, let me see, let me find it out. If I say I'm having these two same, can you see, kids? These two are same, and the third and fourth one also, if I say they are same, like this only. Let me try to find it out something. This is also like this only. These are also same. All four are same. All four, if all four are same, then if I cut it like this, if I cut from this side, this half will go to right hand side, half will go on the left hand side, and this is same as this, and this is also same. All four are same. Then the plane of symmetry will be there or not. Plane of symmetry will be there or not. Do let me know, plane of symmetry will be there. Yes, it will be there. Now if I say 3 are same, so if I say 1, 2 and 3 are same, but 1 is being different, let me say these 3 are same, but this one is different. But then also if I cut it like this, if I cut it half, it will go that side, half it will go that side. These two are same, and this half and half. Then also plane of symmetry is there. In both of these two, plane of symmetry is being present. Both of these two are having plane of symmetry. Now if I say, if I change the two, these two are remaining same, these two are same, but this is different and this is also different. If I say two are different but these two are same, if I cut it, just wait. Now kids, if I cut it, half will go that side, half will go that side, and these two are same. These two are same, this and this same, and this black one, half will go that side, half this side. It is also having plane of symmetry. But if I change all four, kids, if I change all four, if I say this is one, this is another one, this is another one, this is another one, and this is another one. All four, they are being different. All four, they are being different. Now try to cut it. Will you get any plane of symmetry? Half will go that side, half will go that side, but this is different from that. No pause. Now kids, whatever is present, I am taking help of it just to explain. I hope that you can understand, kids. Now, this compound is not having no pause, no cause. Cause I will explain later on. No pause, no cause. So this is optically active. And my dear students, the carbon attached with 4 different groups or atoms, carbon attached with 4 different groups or atoms is known as chiral carbon. This carbon is known as chiral carbon. Or asymmetric carbon. Board is hanging, I don't know. Board is saying, oh, I need break. I don't know, my board is not working smoothly. Now kids, everyone till now you got it. Now my dear students, a compound, if it is having plane of symmetry, even if it is having more than one chiral carbon, if it is having plane of symmetry, then the compound will become optically inactive. This is very, very important thing. Try to understand what I am saying. Compound should be chiral. Chiral carbon is not the necessary condition. Remember that. Chiral, it's not working. Chiral carbons are not the necessary condition, are not the necessary condition for a compound to be chiral, for a compound to be optically active. Then what is the necessary condition, kids? Mark my words, whatever I'm telling you, this is very, very important. Chiral carbon are not the necessary condition for a compound to be optically active. Even if a compound is having more than one chiral carbon and plane of symmetry is there, then the compound will become optically inactive. Remember that. Compounds containing plane of symmetry along with chiral carbons compounds containing plane of symmetry along with chiral carbons. Which carbons? Along with chiral carbons will be optically inactive. Remember that, will be optically inactive. Mark my word, kids. So what is the necessary condition? Necessary condition that compound should be asymmetric. For a compound to be asymmetric, it should not contain, it will become meso. Wow, somebody has written meso. I will explain. Wow, that's really awesome. Kids, you are intelligent. Meso. Now, if somebody is asking, if examiner is asking, what is a necessary condition? One and only one necessary condition for a compound to be optically active, then the compound must be asymmetric. The necessary condition. Compound should not contain any plane of symmetry and center of symmetry, right? Now, let's see. Necessary condition. One and only one necessary condition for a compound to be optically active is compound must be asymmetric, we can say, or we can use another word, disymmetric. With or without chiral carbons. With or without chiral carbons. Remember that. With or without chiral carbons. With or without chiral carbons. Right? This is very tough thing to digest, but kids, remember that chiral carbon is not the necessary condition. A compound can be optically inactive even if it is having chiral carbons along with plane of symmetry, right? And compound can be optically active if it is asymmetric and it is not having any chiral carbon. So chiral carbon is not the necessary condition. But in your school time, you have always studied that a compound with chiral carbon, because in the school only compound with one chiral carbon was coming. And remember that whenever there is only one chiral carbon, then the compound will always be optically active. Now let's find out the chiral carbons. And kids, let me tell you case number 1. So we are going to calculate total number of optical isomers and optically active isomers. Two things we are interested. See, case number 1, when compound doesn't have any pos or cos in any of its representation. That means there is one compound, and in whatever the form you are going to write it down, it is not having any pos or cos. Then total number of optically active isomers will be equal to 2 raised to power n. It's looking like same as GI, where n was active double bonds. Here n is equal to number of chiral carbons, n is equal to number of chiral carbons, right kids? N is equal to number of chiral carbons. And remember that n can be even or it can be odd. Just like GI, here n can be even or it can be odd. N can be even or odd, doesn't matter. Now kids, let's see. Before I move ahead, let me write down its shortcut. Total number of optically active isomers, TNOAI, shortcut, because again we are going to write it down total number of optically active isomers. It is going to take too much time, right? Kids, ready? Now let's see. Before I move ahead, let me tell you one more point. For this case number 1, total number of optically active isomers will be equal to 2 raised to power n, and that is equal to total number of optical isomers. Total number of optical isomers. Now you must got confused. What is the relation between these two? Before I move ahead, kids, let me tell you what's the relation. Actually, or frankly speaking, total number of optical isomers is equal to total number of optically active isomers plus meso isomers. This is the actual formula. But here in this case, TNOAI and this is 0, meso is 0. That's why TNOI, total number of optical isomers, is equal to total number of optically active isomers. I hope that everyone is able to understand. I hope that everyone is able to understand. Everyone, just do let me know you are able to understand. Now let's see example number 1. Example number 1. Lactic acid. Lactic acid is CH3, CHOH, COOH. There is just one chiral carbon. Can you see, kids? Only one chiral carbon. So if we talk about total number of optically active isomers for this, total number of optically active isomers will be 2 raised to power 1, that is 2. Out of 2, 1 will be dextro, another one will be levo. Now kids, it's simple. It's very simple. And these chiral carbons are also known as stereocenters. These are known as stereocenters. Stereocenter, right kids? It is known as stereocenter. Now, formula is telling you everything or just giving the answer, but not explaining anything. Formula never explains anything. Formula just increases the speed. Now, if you want to know this lactic acid in detail, I will move ahead, but let me deal with some more examples. If we write down glucose, now find out total number of chiral carbons in glucose, kids. Glucose is CHO, CHOH, CHOH, CHOH. How many chiral carbons can you see, kids, in glucose? 1, 2, 3, 4. So the value of N is equal to 4. 4 stereocenters we are having for glucose. So total number of, and now see kids, how I am saying that whatever you are writing in any form, this compound you are writing in any form, you will never get any symmetry. See, upside is aldehyde, downside is alcohol. You will never get any symmetry. Now see, total number of optically active isomers is equal to 2 raised to power 4. That is 2 into 2 into 2 into 2. 2 to the 4 to the 8, 16. Got it? They will be 16. I hope that everyone is able to understand. Now if I write down for fructose, if I write down for fructose, kids, just see to it. For fructose, I will say fructose will look like this: CH2, OH, C double bond O, CH, OH, CH, OH, CH2OH and CHOH. Am I right, kids? This is fructose. This is the structure of fructose. Now 1, 2, 3 chiral carbons. So total number of optically active isomers, or I can say total number of optical isomers, that is equal to 2 raised to power 3. That is 8. Everyone is able to understand, kids. Very good, kids. Really rocking, your rock star. Now, kids. Let me go in detail. Let me go in detail so that you can understand each and everything. Sit, kids. If I take example of lactic acid, and if I say one form is CH3, CH, OH, COOH, and if I draw its mirror image, it will look like this. Now kids, they are looking same. They are looking same, but they are not same. They are different. If you see your this hand, if you see is your this hand. Right hand, if you see in the mirror, you will get mirror image as the form of left one. If you see your right hand in the mirror, you will get this left hand. Now, they are looking to be same, but they are different, entirely different. If you take globes with fingers, the right hand globe will not fit into the left hand properly. Have you tried? Just with the finger one globe, if you take right hand one, left hand one, it will not fit. If you take your right hand shoe, it will not fit in the left hand. So that is indicating they are different. They are looking to be same, but they are different. So now see kids, if I say this is rotating the light in anti-clockwise, then definitely this will rotate the light in clockwise. I don't know whether which form it is rotating the light, but if I'm saying this is rotating the light in anti-clockwise, then definitely its mirror image will rotate the light in clockwise. If I say this is a levorotatory, if it is given this is a levorotatory, then this definitely will be dextrorotatory. Which one is small l, which one is small d, that is experimentally determined. But we can say one thing, if one is dextro, another one will be definitely levo. If one is levo, another one will be definitely dextro. So they are non-superimposable. That, see, what does it mean, non-superimposable? If I take my left hand and if I try to superimpose means completely I want to cover it. I will bring my this right hand, it's not covering it up. I am rotating it. Anyhow you rotate it, the right hand will not be able to cover up the left hand. Don't do this thing. That flipping is not allowed. You can rotate your right hand on the left hand. Whatever practice you are going to do, it won't be able to cover up. By chance, if thumb is not there, then the plane of symmetry is there, then it will definitely cover it up. That is the point. If a compound, now see this hand is not having plane of symmetry, from wherever you cut it, don't cut it, just imagine it. If you try to cut it, you will never get any plane of symmetry. If there is no plane of symmetry, then compound and the mirror image can't be superimposable. Everyone got it? So these two are non-superimposable mirror images. Non-superimposable mirror images. And there is one word that is known as, these two are enantiomers. These two are enantiomers. You got it? So if I say this is A, this is B, A is the enantiomer of B and B is the enantiomer of A, just like sister is the relation, enantiomer is also relation. So these two we can say are enantiomeric pairs. A and B are what? A and B are what, kids? Are enantiomeric pair. A and B are enantiomeric pair. Everyone clear? Is it clear, kids? Do let me know in the chat section. Is it clear to each and every one of you? Now, kids, if I add 50% dextrolactic acid and 50% levolactic acid in a same beaker, then what is going to happen, kids? What will happen? Just do let me know. If I allow the plane polarized light to move through it, if I allow the plane polarized light to move through it, kids, what will happen? Do let me know. Dextro will rotate the light in the clockwise direction. Levo will rotate the light in the anti-clockwise direction. Once the light is coming out of the solution, in which direction will you see the light is being rotated? Suppose I am light, plane polarized light. Dextro has rotated in the clockwise direction. With the same magnitude, Levo has rotated me in the anti-clockwise direction. Now the light will be, once it is coming out, it will be getting rotated or will look like nothing has happened to the light. Outside it is coming out, it will look like that nothing has happened. That means this is known as complete racemization has taken place. Complete racemization has taken place, and the mixture will be known as optically inactive. Mixture will be optically inactive. Mixture will be optically inactive. Now, kids, you must have studied that 50 milliequivalents of acid and 50 milliequivalent of base, if you're going to react, then the solution will become optical amines, neither acidic nor basic. Only salt and water will get formed. Only salt and water, right? Complete neutralization will take place. On the other hand, if I say that in the beaker, I'm in the beaker looking at you. In the beaker, I have taken, suppose, 70% dextrolactic acid and 30% levolactic acid. Now, the same light is passing through it. Plane polarized light is moving through it. What will happen, kids? The dextro one will rotate the light in the clockwise with more magnitude because it is in more amount, and levo will rotate in anti-clockwise, but the light will rotate like this because levo has rotated in less amount, so light will be seen like this. Even though the light has been rotated in both the direction, but still it is dextro. Why? Because dextro was more. So we will say partial racemization has taken place due to partial racemization. Mixture is still optically active. I hope that everyone is able to understand. If you take 70 milliequivalents of acid and 30 milliequivalents of base. Neutralization will take place, but this neutralization to form salt and water will be partial. Still, because of excess of another reagent, one was limiting reagent, one was excess, the excess of acid is still present. So that is known as enantiomeric axis. This is still active. Why it is still active? Due to enantiomeric axis, due to everyone got it? Kids, this concept is clear? If yes, the clarity is there, then I want to see green hearts in the chat section. Everyone just to let me know. Everyone just to let me know. This concept clarity is there. Now, let's deal with case number B, where the meso will come. Meso will get entry, right? Case number B. Everyone ready for case number B, kids? Just to let me know. Case number B. When compound is having plane of symmetry, plane or center of symmetry, in any of its structural representation, in any of its space arrangement, then two subcases arises. Then two subcases, just like GI, arises. What are these two subcases? One with even number of chiral carbons, another one with odd number of chiral carbons, right? Even chiral carbon, odd chiral carbon. Now let me tell you, kids, the GI formula I have given for even number of active double bond will be same for this one also. Let me show you, kids. Even number of chiral carbon, subcase with even number of chiral carbon. Then kids, if I talk about even number of chiral carbon, total number of optical isomers, total number of optical isomers is equal to total number of optically active isomers plus meso isomers, right kids? In first case, no meso isomer was there, but here meso isomers will be there. 2 raised to power n minus 1 plus 2 raised to power p minus 1. If you remember, when I taught you for GI, when there were even number of active double bonds, the value of P, as I have told you, what was the value of P, kids? What was the value of P? The value of P was n by 2. Here also it is n by 2. Only the difference is that here n is chiral carbon and there the n was number of active double bonds. Now let's see, let's talk about tartaric acid, then you will get the answer. Just see tartaric acid. Let's take example, well-known example of what? Now tartaric acid. Do you know the formula of tartaric acid? Now examiner can even ask what is the formula of tartaric acid. So remember that this is tartaric acid. CH3, no, COOH, CHOH, CHOH, COOH. This is tartaric acid. And how many forms we can write tartaric acid, that is another thing. But see, you stand in the middle of compound. What is the middle of compound? This is the middle. Can you see? This is the middle. Now how to find out which case it is? Because in the examination, no one will be there to tell you which case it belongs. It is from case A or it is from case B. It is subcase X or Y. No one is going to tell you. Now how to do it? Just see, go on the right hand side. As you move on the right hand side, whatever you are getting, now move on the left hand side. Do you think same appearance is there? Right hand side and left hand side. If the same appearance is there, then definitely it means in any form the plane of symmetry will come. Suppose if I say in my one hand there is marker and in another hand there is this type of scissor, and God has made it me like this. Now in any form, if I stand in any form, there will be no plane of symmetry because this right hand side and left hand side, they are different. Till now this is same, but at extreme right and extreme left they are different, so never plane of symmetry will come. But by chance God has made me like this as am I. Now see, if you don't see the internal organs, liver, heart. Now if I am standing like this, no plane of symmetry. Standing like this, no plane of symmetry. But if I stand like this, plane of symmetry will come. In this form, this space representation, definitely plane of symmetry will come. So kids, whenever you are moving, always go on the right hand side and left hand side. You see the same appearance is there. Now this is one chiral carbon, this is another chiral carbon, two chiral carbons, so even number of chiral carbons. Can you see? Can you see? Now total number of optically active isomers, total number of optical isomers is equal to total number of optically active isomers plus meso isomers. What formula we have written over there? 2 raised to power n minus 1 plus 2 raised to power n by 2 minus 1. This we have written. So how much it will come out? 2 raised to power 2 minus 1 plus 2 raised to power 2 by 2 minus 1. So total number of optically active will come 2 and meso will come 1. So total number of optical isomers 3, out of which 2 are optically active and 1 is meso. 1 is meso. Now formula has given you each and everything, but we are not able to understand this in detail. How many of you want to visualize it, kids? Do let me know how many of you want to visualize it. Because formula is just giving the speed but not making you fundamentally strong. But how many of you want to visualize it? Now see, let's go with the visualization. If I write down tartaric acid, now kids, if you put a line and try to divide it, upper side is OH, lower side is H. No plane of symmetry. You see, if I'm trying to cut it from here, upper side is OH and lower side is H. No plane of symmetry. Can you see? No plane of symmetry is there. Let us suppose if I say the light is getting rotated, no light is there, but let's suppose light is rotating anti-clockwise, then here also light is rotating anti-clockwise, and if I say this is LIGO, then its mirror image will be C. Its mirror image will be clockwise. So if I say this is dextro, this is small l, then this will be, suppose this is, I say small l, then this will be small d. Enantiomeric pair, both are optically active, because neither this one is having pause nor this one is having pause. So these are enantiomeric pair. Everyone, are you getting my point? Now at the same time, these two are optically active. Always enantiomers are always optically active. Total number of optically active isomers 2. Now at the same time, if I put OH over here, OH over here, now try to divide it in 2 equal parts. Will you get success or not? If I try to divide it from here, I put my sword over here. Just see, is it dividing it into 2 equal parts? Tell me, kids. Is it dividing it into 2 equal parts or not? Just see, kids. Is it dividing into 2 equal parts? Do let me know in the chat section. Plane of symmetry is present because upside is OH, downside is also there. Upside is H, downside also. So even though 2 chiral carbons are there, but it is having plane of symmetry. Now see, if I say from OH, if I go from OH to H, this is moving anti-clockwise and another half is moving. Just to let me know, another half is moving clockwise. So half of the portion of compound rotating the light in clockwise and another half is rotating in anti-clockwise. So it is optically inactive due to internal compensation, internal compensation. And kids, there I have told you about racemic mixture, that was optically inactive due to, this was optically inactive due to external compensation. Why external? Because here one compound was cancelling out the rotation of another compound. So there were two compounds. So this is external compensation. And this is due to internal compensation. And whenever there is internal compensation, the compound is known as meso. Now the mirror image of meso will also be meso. Its mirror image will be meso, and they will be treated as identical. Two mesos are treated as identical. So total, this is optically inactive, but it's still rotating the light. Half of the portion is rotating the light in clockwise, another half is rotating anti-clockwise. So still it is optical isomers. Don't forget that is optically inactive, but still optical isomer. It is still optical isomer because it is rotating the light. So total tartaric acid is having how many optical isomers? Now let me write down. If anyone is asking, tartaric acid is having how many optical isomers? Do let me know in the chat section. Answer is 3 optical isomers. Now if somebody is asking how many optically active isomers? Then these will be 2. How many mesoisomers? Then these will be 1. Got it? 2 optically active, 1 optically inactive. That optically inactive one is meso, and rest of 2 are dextro and levo. Got it, kids? Do let me know in the chats. Everyone comfortable? Everyone? Yeah, Dhanak, I remember. Now, this is clear to each and every one of you. Just after 5 minutes, we are going to have another day. Okay, Friday will get started. Now kids, one more case is left. After that case, R and S I will teach. Then the class will get ended. Okay, kids? Write down something in the chat section. After that case, we will deal with R and S configuration. Once R and S got completed, that means this chapter will get completed. Thank you, Muban, Kashim. Thank you, kids. Write down something before we start the last case. Days are going so fast. Chetra, wow, Chetra, great, Chetra. Conformers, yeah, I will teach conformers also. Don't worry. Conformational also, I will let you know. Chaitanya Maskare, welcome. Chaitanya, you said one day take 8 hours class. So today that dream is coming true. Now kids, let's it go. Case 2. Case 2. Subcase B. Only once they have asked question in AIMS, that is odd number of chiral carbons. So that question was given like this: COOH, CHOH, 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 COOH. Now in the examination, how you will find it out that it is the same case? Just see. Just sit at the center of the compound. Just sit at the center of this compound. This is the center, suppose. This is the center, right? Now go on the right hand side. Move on the right hand side. Whatever you are getting, see the same thing you are getting on the left hand side or not. Right hand side and left hand side are same. That means it belongs to the same case. Now one chiral, second chiral and third chiral. Now my dear students, this one is known as pseudo-chiral. I will explain in detail. This one is known as pseudo-chiral or pro-chiral. And this is pure chiral. And this is also pure chiral. Two are chiral, or this is pure chiral. This is also chiral. Two are chiral, one is pro-chiral, pseudo-chiral. Now why it is known as pseudo-chiral, I will explain. First of all, you can remember that total number of optical isomers are 4. Total are 4. How will you divide these 4? 2 are total number of optically active isomers and 2 being meso. 2 and 2 coming out 4. Total coming out 4. Now, this is the answer. If you remember this much, you will get full marks. But we are not going to cram. We have to understand in detail, and that is the thing I've told you in the starting. Fundamentally, you are supposed to be, wow, fantastic, fantastic. It's 2 meso, yeah, and 2 optically active. So see kids, let's see in detail. Let me write down all the 4. Now kids, see, do you think this compound is having any plane of symmetry? The answer is no. So it is having 3 chiral carbons, no plane of symmetry. Sir, why you are saying chiral? Yes, I will just listen. I will explain each and everything. This is chiral. This is also chiral. This is also chiral. No plane of symmetry. That means it is optically active. Now kids, it's a mirror image. It is also having 3 chiral carbons, and this is an enantiomer of that. So no plane of symmetry. This is also optically active. Now these two are enantiomeric pair and these two are optically active. These two are enantiomeric pairs, right kids? Now just try to understand this one kids. See to it. Now do you think this compound is having plane of symmetry? This compound? So the answer lies yes. This compound is surely having plane of symmetry. If we cut it from here, you can see we will get plane of symmetry. Can you see? This is plane of symmetry. So this compound, even though it is having how many chiral carbons? See, this is chiral, but this is not chiral. Now you must be thinking, sir, what are you talking about? This one is not chiral because from here plane of symmetry is moving. So this is not chiral. So sometimes it is becoming chiral, sometimes it's not becoming chiral. In some cases it is being chiral, some other cases at the same time it is not chiral. That's why it is false chiral. It is false chiral. So pseudo chiral we have done. Now its mirror image will be identical. Now see, this is meso. But this meso is entirely different from this meso. Let me write down. See. This is also meso. See, kids. But this meso is different from that meso. Why it is different? Try to notice that all the 3 OH are on same side, but here 2 OH are on same side. One is on different side. That's why it is different from that meso. But here also plane of symmetry is present. Can you get it, kids? Plane of symmetry is present. So this is also meso. There are 2 meso which are optical isomers but not optically active. Everyone is able to understand? Do let me know in the chat section. Thank Kumar. Thanu Kumar. Okay, I will. Yeah, that's why it is false chiral. Everyone got it? Now, only R and S configuration is left. So can we take 15 minutes break? Then we can start R and S configuration. Kids, you can charge your mobile, you can charge yourself. So after the break, we will start R and S configuration. It will be okay? Good for everyone. Good morning, Hames. Good morning. Everyone, can we take break? Okay. Yeah, definitely I will teach. Thanu Kumar, definitely. So let's meet at what time? What should I write? What should I write? Let's meet at what? What should I write, kids? Let's meet at what time should I write? What time should I write? Let's meet at how much time should I write? 0.20, right? AM. This is right or wrong? This is right or wrong? This one is right or wrong, kids? 12:20, 12:30. Kids, are you back? Just to let me know. We are going to start with RNS configuration. But first of all, let me write down something. Types of configurations. Are you back, everyone? Just to let me know, kids. Are you back? Types of configurations. First one is absolute configuration. Absolute. That is RNS. This is in detail. We will study because this is very, very important. Everyone, yeah, I want to see green hearts, some fire in the chat section. If you can hear me, can see me, kids. Yes, everyone from each and everyone's side. Now, second one is trio and array trio, and before that, capital D and capital L configuration. This is relative configuration. It is not in that much detail, but yeah, it's important. Now, I would like to say the third one is trio and array trio. And last but not the least, small d and small l. This is being experimentally determined. We cannot say whether the compound is dextro or levo. This is experimentally determined. So this absolute configuration is very, very important. So we have to deal with. Yes, coffee to nahi, I don't want to have coffee, but yeah. Now see, kids, RNS and Fisher projection, right? Now, Fisher projection is written like this. And if I write down some compound like iodine, bromine, chlorine, hydrogen, only what you are supposed to do right now, just few minutes back, I told you CIP rule. According to CIP rule, can you please help me that which one is highest priority group? This is most senior, then this one, then this one, and this is on fourth number. This is known as LPG. What is the full form of LPG? Least priority group. Now remember that, make an arrow moving from number 1 to number 2 and write down it is moving clockwise. Almost everything is done. If you know CIP rule, then you can do anything. According to CIP rule, I have written that. Now remember that if LPG is on vertical line, if LPG is on vertical line, then remember that for clockwise arrow, if the arrow is moving clockwise, we will say it is R configuration, and if it is moving anti-clockwise, we will say it is S configuration, R and S configuration. This is the first point. But if LPG, if least priority group is on horizontal line, then opposite. Then we will say for clockwise arrow it is S configuration, and anti-clockwise arrow it is R configuration. But my dear students, we are human beings. As the time passes, we forget. Wow, ring star. Now ring star has written, if once we are forgetting this thing, so there is one trick. There is one trick. What is that trick? It is related with LPG. HARVAS. My name is Harendra. Harendra is very awesome. Very awesome. Very awesome. Right? Now, this H means if LPG is on horizontal line, arrow is moving anti-clockwise. This is a horizontal. This is anti-clockwise arrow, then R configuration. If LPG is on vertical line, are you getting my point, kids? It is on vertical line, anti-clockwise arrow, then S configuration. I hope that everyone got it. So kids have written, ring star has written, Harendra is very awesome. HCS VCR. HCS VCR. So just for right now, you can remember these two things. So see kids, in this compound you have seen where it's gone. Yeah, this compound, the LPG is on vertical line and arrow is moving clockwise. So it is R configuration. Got it? R configuration. R configuration. I hope this is clear to each and everyone. Everyone has got it. Everyone is able to understand. Now, my dear students, one more thing I would like to tell you, that while moving from 1 to 2, if some problem is arising like this, 1, 2. Now just write down according to CIP rule, this is 1, this is 2, this is 3, this is 4. 4 is LPG. While moving from 1 to 2, you cannot go like this. This is the wrong path. Everyone crosses the lowest one, so this is the correct path, and it is moving anti-clockwise. LPG is on vertical line, arrow is going anti-clockwise. So what should I write? I will write S configuration. Got it? Configuration is S. Everyone, I hope that everyone is able to understand. Everyone got it or not? Just to let me know, everyone got it or not? Is each and everyone is able to understand or not? I want to see green hearts, kids. Kids, do let me know fast, kids. I want to see that everyone is able to understand or not. Now see kids, the application of it. What's the application of it? Let's see kids. This is having very awesome application. Just see. If I draw these compounds, which you have already studied, now see, If I say this is chiral carbon, number 1 should be given to do, number 2 should be given to this, number 4 should be given to this. This arrow is moving anti-clockwise and least priority group is on horizontal line. So LPG is on horizontal line and arrow is moving anti-clockwise. This is R. And you have seen this compound was optically active. So definitely this will also come R. If this is R, definitely this will also come R. Let me show you, kids. Number 1, number 2, arrow is moving anti-clockwise and this is on horizontal line. This is also R, and if this is R, definitely its mirror image will be, kids, this is going to happen a magic. Its mirror image will be definitely S and S, S and S. It will be S and this will be S. And if I draw meso, then half of the part will be R and another half will be S. Just see to it, kids. One half will be R, another half will come out to be S. If I go from here, this is moving, this is over here, anti-clockwise, this is R. So definitely this will come out to be S. See, this is moving clockwise and this is S. So this is meso. This is the best application of R and S configuration. Got it, kids? So I can say R and our relation with S and S is enantiomer. They are enantiomers. And if I say RR with RS or SS with RS, the relation will be, they will be diisomers because they will not be mirror images of each other. So this is really a fantabulous thing. This is really an awesome thing. Kids, got it? Now let's move with RNS in RNS configuration in flying wedge and dash formula. RNS configuration in flying wedge dash. R and S configuration in flying wedge and dash. Now kids, what you're supposed to do, suppose if I take one compound, one valency is coming towards your side, one is going away from you, one is in the plane of paper, another one is also in plane of paper. What you're supposed to do, what you're supposed to do, just do one thing. Whatever is attached on dash line, whatever is attached on dash line, whatever is attached on dash line, put it on vertical line, put it on vertical line. Whatever is attached on dash line, what I'm saying, kids, whatever is attached on dash line, put it on vertical line, either top or bottom, and keep rest of the atoms same. Rest of the atoms same, Br, chlorine, iodine. Whatever is the configuration of this compound, same will be for this. Let's see what configuration we are getting. Arrow is moving clockwise and LPG is on vertical line, R configuration. So its configuration will also be R configuration. Let me write down another one. If you're thinking that, let's draw another one. This time I'm going to keep dash one at the top. I have kept over here rest of the groups as such: bromine, chlorine, iodine. Now let's see, kids. 1, 2. Arrow is moving clockwise. This is our configuration. So they all are being identical. Configuration will not get changed. I hope this is clear to each and every one of you. Now let's deal with relative configuration, that is capital D and capital L. Capital D and capital L, that is being relative configuration. From which it is getting related kits. Let's see. If I say this is the compound, Fisher has said always the top priority group should lie at the top. HOH, CH2OH. Now this OH and this OH, last and second last OH, if they are on same side, remember that this is actually glyceraldehyde. If they are on same side, we will say it is D, capital D. It has nothing to do with small d, capital D glyceraldehyde. And if they are on different side, for example like this, CHO, CHOH and CH2OH, they are on different side. These two OH are on different side. We will say L glyceraldehyde. That's it. This is simple kids. This is in carbohydrate. This is in carbohydrates. In carbohydrates. And second thing, they can ask about it in amino acids. They can ask about it in amino acids. Are you listening, kids? Everyone, you are active or not? Are you active or not in amino acids? Let's see in amino acids. Now, all amino acids are optically active except glycine. Now, if compound is given like this, NH2, CHR, COOH. Now remember that if COOH is coming on second position according to CIP rule, if COH is coming on second position according to CIP rule, and for R configuration we will write down D, and for S configuration we will write down L. This is the funda. So generally in your examination you will get this thing only. You will get this thing only. If by chance COH is coming in, there are very few amino acids. COH will come on third position, then we will reverse it. But this is simple one. So just seek it. Or number 1 should be given to nitrogen, number 2 to this, number 3 to this, number 4 to this. Arrow is moving clockwise. Arrow is moving clockwise, but it is over here. So we'll say S configuration, S. If you don't remember it, you can say when LPG applied trick is on horizontal line, arrow is moving clockwise, so S configuration. S means it is L. So it is L amino acid. Now the last one but not the least one, trio and erythrio. In last 25 years, they have asked only once trio and erythrio. Let me tell you trio and erythrio. Now see kids, as the name is indicating, in the name only answer is hidden. In the name only answer is hidden. See kids, if I say on this line, standing line, if I say trio, so it will start with T. This same thing is going on right hand side. The same thing is going on the left hand side. So this is the trick. It is trio. It is trio. BR and BR, same thing is going on opposite side. Now if I write down erythrio, the same thing is going on same side. The same thing is going on same side. The same thing, that means same thing is on same side. Erythrio. In the name only answer is hidden. Everyone, is it clear? Is it clear? Trio and erythrio. Everyone just to let me know. Now kids, RNS configuration, I have told you each and everything I have told you in about RNS configuration. So optical isomerism is done and dusted. Now what is left kids? What is remaining? Only one thing is remaining, that is conformational isomerism. And I am going to start with conformational isomerism. Is everyone ready kids? I've told you each and everything about trio, erythrio, everything. Just see, the name is indicating over here which one is trio, which one is erythrio. This is a nice trick. If you're liking it, I want to see some fire in the chat section. If you're really enjoying it, kids, do let me know. Show me fire in the chat section. Everyone, you are getting it. You are able to understand it. Now just 15-20 minutes we will take just for conformational isomerism. Last topic, conformational isomerism, right? Now, kids, are you ready for conformational isomerism? Just to let me know. I want to see in the chat section that everyone is ready for conformational isomerism. Conformational isomerism. Ready kids? Now see kids, we will start from the scratch about the conformational isomerism. Which compound will show conformational isomerism? That is the most important thing. Necessary condition for a compound to show. Necessary condition to show conformational isomerism. What is that necessary condition? 3 regular sigma bonds should be there. At least 3 regular sigma bonds. At least 3 regular sigma bonds are required kids. Now see, 1, 2 and 3. For example, if I say H2O, how many regular sigma bonds are there? 1 and 2, so can't show. If I say H2O2, hydrogen peroxide, 3 regular sigma bonds are there, so it will show. If I say methane, so there are 4 covalent bonds, but they are not regular. Regular means count like this. So these are only 1 and 2, so cannot show. Ethane, how many regular sigma bonds are there kids in ethane? 1, 2, 3, so it will show. Got it, kids? One thing is clear. The point from where we have to start the conformational isomer. Methane will never show conformational isomer, but ethane will show, and ethane will have infinite conformers, right? Ethane will have infinite conformers. These are also known as rotamers. These are also known as conformational isomers. Now, kids, if I say what Fisher has seen, what Newman has seen, but before going ahead, let me tell you, two are extreme. Two are extreme. Out of infinite conformers, two conformers are very, very important. Why these are very, very important? Because one is more stable, another one is least stable. The most stable and the least stable, the very good person and very bad person. There are a number of persons in this world, but we talk about very good and very bad. Just like that, the one is most stable and one is least stable. We have to focus on most stable and least stable. Otherwise, there are infinite conformers, right? Got it, kids? Now, let's see. One scientist was there. His name is, yes, his name is Sohars. Sohars has seen compound from the side view. He has seen side view and see how he has written ethane. He has written ethane like this line, tilted line has been drawn, and then on this Y like Mercedes sign is drawn like this, Mercedes sign. And this is, if I draw just opposite Mercedes sign to this regular Y and inverted Y. And if I put hydrogens over here, this is carbon, hydrogens over here. Now see, this hydrogen is just coming in between these two hydrogens. And this hydrogen is coming in between two hydrogens. So we will say it is staggered form. Staggered means all the atoms are far away, and all the atoms are far away. That means atom repulsion is minimum. Atom to atom repulsion, he said it's van der Waal repulsion. What he called it? Atom to atom repulsion. Van der Waal strain is minimum. What is van der Waal strain, kids? Atom to atom repulsion. And the atoms are attached with electrons, so this is known as torsional strain. This is known as torsional strain, that is also minimum. Bonded electron repulsion, bonded electron repulsion is known as torsional strain. TS is torsional strain. Now, if it is doing conformational isomerism, then there will be one position like that where hydrogen will be at the nearest distance. One hydrogen will collapse with another hydrogen, kids. One hydrogen will collapse with another hydrogen like this. This hydrogen, they are exactly getting eclipsed. They are getting eclipsed. So hydrogen, if you try to see, hydrogen is just at the back of hydrogen. So eclipsed form. So in eclipsed form, atoms are nearest. So van der Waals strain is maximum. Torsional strain is also maximum. So that way it will lie less, and this will mainly spend its maximum time toward this side. This is more stable, that is less stable. This is most stable form, and that is being least stable. Now kids, the same thing is observed by Newman. Newman has given a better view, because Newman has seen it from the front side view. Now Newman's projection. He has seen from front view. He said the front carbon is drawn with small dot. Front carbon is drawn with small dot, and back carbon is drawn with big circle. Okay, try to understand. Front carbon, back carbon. Front carbon with small dot, back carbon with big circle. Now, if we want to draw ethane, so we will draw it like this. Front carbon attached with three hydrogens. Are you getting my point? Front carbon attached with three hydrogens, and the back carbon is like this. It is also attached with three hydrogens. Now visibility is clear that there is maximum distance. This is staggered form. You can see clearly. Van der Waals strain is minimum. Torsional strain is minimum. So more stable. Now if it is doing conformational isomerism, then another form will come like hydrogen will be just behind of hydrogens. So see kids, hydrogen will be most behind of these hydrogens, these hydrogens, these hydrogens. Now atoms are nearest to each other, their bonded electrons are nearest to each other, so the repulsion will be maximum. Everyone getting my point, kids? Repulsion will be maximum, that the van der Waals strain is maximum, the torsional strain is also maximum. This is eclipsed form. Now my dear students, the angle between these two bonds, that is known as dihedral angle or torsional angle. Dihedral angle is 0. This is also known as torsional angle. Here dihedral angle or torsional angle is of 60 degree. Torsional angle is 60 degree. I hope everyone got. This is most stable. That is least stable. So definitely the equilibrium will lie maximum toward that side and least toward this side. Rest of all the form in between these two will be known as gauche. Gauche we can say, or we can say skew or gauche. So this is about ethane. Now it is indicating that will it be always like that? Staggered form will be more stable? No, kids. Whenever there is case of intramolecular hydrogen bonding, then gauche will be more stable than staggered. Where the intramolecular hydrogen bonding will take place, let me tell you, let me explain. It will take only 5 minutes more, kids, not more than that. Are you ready for that? 5 minutes more. Just 5 minutes more, right? So, if I draw butane, first let me explain. If I draw butane, so how I will write butane, kids? I will write like this: CH3, CH2, CH2, CH3. Now, if I take this carbon as front carbon and this carbon as back carbon, just try to understand. Front carbon. So I will draw front carbon. What is that as? 2 hydrogen and 1 methyl. So I will say 1 methyl and 2 hydrogens. Let me make Y. I am adding 1 hydrogen and 2 hydrogens and 1 methyl. On this 2 hydrogen and 1 methyl back carbon, I will draw with big circle, right? And I will add on that also 2 hydrogen, 1 methyl, 2 hydrogen, 1 methyl. Just see 2 hydrogens, 1 methyl. Now I'm keeping in my brain that they should remain opposite to each other. So see, this compound's representation is that bulky groups are opposite and they are far away from each other. So I will say it is an anti-staggered form. Anti-staggered form. Now let's do one thing, kids. Let me make green to be fixed. Okay, let me make this one to be blue. Okay, so that you can understand better. So let me make blue to be constant and let me rotate green. Blue to be fixed and let me rotate the greener one. Oh, what is green? What is blue? So let me make them to be blue, fully blue. Otherwise you will get confused. This is blue, this is blue, this is also blue. So blue and orange. Let me make blue to be fixed and let me move the yellow part. A time will come if I move from here to here 180 degree. Then what I will get? If I move 180 degree, if I move through 180 degree, what I will get? What I will see, kids? If I move, let me keep blue to be the fixed one, blue to be on fixed position. And if I'm moving orange one by 180 degree, then what I will see, kids? Do let me know. After some time, what I will see? That the position will be like this, eclipsed and fully eclipsed form I will get fully eclipsed form, the least stable form. Am I right, kids? This is the least stable. That is being most stable. And in between this, if I move it by 60 degree, just rotate by 60 degree, what I will get? If I say I am rotating it by 60 degree, keeping blue to be fixed, blue to be fixed, rotating orange one in the clockwise direction by 60 degree, what I will get, kids? This is methyl. I got eclipsed one, but this is not fully eclipsed because methyl can't be get fully hidden by this methyl has gone over there. Hydrogen will come over here. Hydrogen. This is not fully eclipsed. This is partially eclipsed. I can say partially eclipsed. Now, if examiner is asking that out of these three forms, which one is more stable? Anti-staggered, then staggered, then partially eclipsed, then fully eclipsed. That is least stable. So anybody is asking about butane, then most stable. For example, if they are asking about butane, then who will be most stable? Anti-staggered will be most stable, kids. After that, staggered. After that, partially eclipsed. After that, fully eclipsed. I hope everyone got it, kids. This is the stability order, and that is the reactivity order or energy order. Now only 2-3 minutes are required. Lecture will get over, kids. Kids, first of all, do let me know that I've started from the scratch and I have completed each and everything without leaving even a simple thing, without leaving even a single thing. I've covered up each and everything or not. Special note. Do let me know in the chat, kids. In case of intramolecular hydrogen bonding, gauche will be more stable. Gauche will be more stable than staggered. Hydrogen bonding, you know very well in which atoms hydrogen bonding takes place. Gets? Now see, the best example is ethylene glycol. You know that here intramolecular hydrogen bonding, let me represent it. Front carbon OH, H, H, back carbon OH, H, H. Now see, this is Gauche, and in Gauche, in between this H and O, there is intramolecular hydrogen bonding, Gauche. And if I say, if I draw its staggered form, now do you think because of too much distance in this between this hydrogen and this oxygen, intramolecular hydrogen bonding is not possible? So who is more stable, kids? Definitely answer is Gauche is more stable than anti-staggered. Got it, kids? Everyone? Stabilized by intramolecular hydrogen bonding. I've completed, kids. Each and everything is being completed. This chapter is completed. Kids, do let me know how much you have enjoyed, and thank you for being with HSP in Army. Thank you for giving really awesome answers. And kids, I have completed each and everything. I've gone through each and everything. I've told you each and everything so that you can understand each and everything, kids. Questions, whatever I have given over there, they will ask question from this point only. Ha, Priya ji, Chaitanya, thank you. But Priya ji is missing. Yes, you are right, Chaitanya. But Chaitanya, do let me know. You were asking, sir, take class, long class, marathon class. I've completed each and everything, kids. So I would like to see the comments after this video is over. Not in the live one, but once it's completed in the form of comments, right? Priya ji is ill. Okay. Take care. Ask her to take care. Okay, kids. I hope that everyone has enjoyed a lot. Everyone is going to gain maximum from this. And kids, do proper revision. If you want to get good marks, proper revision should be there. If you're doing proper revision, you're really going to get maximum from it. Okay, kids? Will you do proper revision? Yes, do promise that yes, sir, we will do each and everything in detail. We will take care of proper revisions so that we should get good marks. Right? God bless you, kids. Love you, kids. May Almighty God bless you with all happiness and prosperity. Bye bye. Take care. God bless you. All the best. Okay? Done and dusted. Yes.